Good morning. Merry Christmas, folks. Let me get the chat working. Where'd this thing go? View. Docs. There it is. Perfect. So, I've been gone a while. I'll wait till a few people are here before I tell that story. But I took a vacation. I am back. And I still have some other stuff I'm going to be working on off stream here and there. But I'm in Florida now. And the goal is going to be to just crank out the rest of Puffer 4.0. There are quite a few things in order to do that. Merry Christmas to you as well. There are quite a few things left for the 4.0 release. The main one is taming the low-level mess with Torch and figuring out how I'm going to structure everything, getting everything numerically stable, and hitting our 10 mil performance number. Once we get that, it's just a ton of experiments and some tweaks to Constellation, for the most part. Let me show you guys a little bit, because I did do a few things off stream over the last several days. So let me just go ahead and show you that. This is from yesterday. I've been experimenting with Torch compile on chunks of C++ instead of on chunks of Python. But the main thing that I did while I was away we now have a working C, not C++, threading vectorization implementation. And this thing also does GPU buffering. So this is dramatically faster in almost all cases than what we had before with Puffer. And what we had before with Puffer was already state-of-the-art. So this is going to be a nice performance boost for pretty much everything, including some stuff for our clients and including some stuff for partnered labs. So I'm very excited to get this out there. It's going to still take a little bit more work, and we have some other things to do before I can finish this up. But what we're going to do on stream today, my plan for today is to attempt to tame Torch compile. Let me show you what I mean by that. So the thing that I realized is CUDA launch overhead is a problem. That doesn't go away in C++. You just get rid of the Python overhead. And there are two ways to get rid of, two realistic ways we can get rid of CUDA overhead. One is with CUDA graphs, which is not through PyTorch, though there are a couple hooks into it. And the other is with Torch compile. Now, I'm a little bit conflicted on this because if I add the CUDA graph support directly to native C++, I'm kind of doing something outside of what Torch does. I don't really get all the same things that Torch compile gets. It will kill the launch overhead, but it's then pretty difficult for me to take chunks of the C++ or the C++ for Torch, the C++ Torch code, and bind it to Python, because I'm going to want to bind chunks in between CUDA graph bounds. Also just adds a whole bunch of code. Now, I could use Torch compile right over chunks of the code, but the problem with Torch compile now is, for whatever reason, and this drives me insane, I really do not like the way Torch compile is implemented. It's entirely written on the Python side. And it's done so in a way where you cannot easily go to the C++ bounds, even though that's exactly what you'd want to do. So I have to expose certain things to Python in ways that change how I have to write the C++ a little bit. But I think this is worth experimenting with, because my hope, and the reason that I think that this is now worth doing, is because I have most of the network in C++, I think that the compile time overhead should be very small compared to what it used to be. And I think you're still going to get quite good performance without it. So we're going to try that. And the problem is, even if I do coup de grace is also going to introduce launch overhead because it's the same sort of tracing operation. Audio only working on Twitch. I don't remotely know how that's possible. Seriously? Hang on, let me check. How the heck is that even possible? Test. Is this working? Hello? Huh. Test. Is this working? One moment. Hello? Huh. Test. Is this working? One moment. Please. Hello? Audio's working on X perfectly. Test. Well, I can't hear myself. Is this working? One moment. Please. Hello? I can hear you down on YouTube. Alright, thank you for the false positive report, my friend. Great. I'm not starting off the news stream with completely messing up my setup. No video is on YouTube, really? That doesn't make any sense. Oh, hey, we hit 5K at some point. This looks like it's working to me. Alright, where were we? So, the thing that we're going to do with torch compile, right? We're going to see if the overhead is not as bad when you have big chunks of your net in C++. I think it should be fine if we do it this way. Have I gained weight? I've gained... Well, not actually since I left. Since the summer, I've gained about 4 or 5 pounds back on mostly muscle. But I lost... Before the summer, I lost 18 pounds, or like over the summer in 6 weeks. On a big cut. And now I'm actually... I will probably end up putting some fat back on because I'm trying to get back into some heavier training. Started squatting again and whatnot. Okay. Yeah, so I guess the thing that is still to be seen, which is that I could do this all day today and it could still not work, is torch compile could still be a mess, even with big chunks of the network in C++. But the only other option is to do everything manually with coup de grace. And the thing that really puts me off of that is you don't get kernel search if you do it that way. So you don't even have the option to try like max auto-tune for better kernels or anything like that. So I'm going to try this. The goal for today is like really clean implementation with torch compile and C++ networks, and we're going to see how things work from there. Okay, so to start this off, I believe right, so we're trying to compile the forward pass of the policy here. And I believe that the difficulty here was, right. So I actually went and grabbed Claude for this because there's literally not even to like write code, but because there are no docs anywhere. Like there literally are no docs for this. So we're gonna see if this is made up bullshit. Grok just gave me made up bullshit that didn't work. It wasn't even part of the API. So this essentially says, because there is no documentation in Torch for what I'm supposed to do with like full network forward passes. According to this though, What is it? Oh, actually, it did make up some bullshit, and then I gave it the LSTM source. Okay. Yes, that's what it was. So apparently, you can bind ops like this. Def forward. Apparently, this works. We will see. I'll put this over on my other monitor. And this is what we're going to try. So first thing, I think this is one of the things that I really needed to take a vacation from as well. Like this whole API, the way they do all their C++ is so fiddly. It's very difficult to make any progress quickly. And it's really not, it's sort of a C++ problem, but it's not like a low-level dev problem. It's just like an engineering own goal. It's just really not designed very well. All right, so here we can define, this should be, so this needs to get policy forward. And then this needs to also get, we need a definition for the, was it the meta kernel? But I think that this is the same. So here, let me explain something. So this thing here, this is the meta kernel. This is actually not recommended by the Torch authors themselves. They actually have several points where they recommend that you do this. This instead, policy port abstract. You do something like this. But then this one is bound to the wrong op, right? Yeah, because this is the wrong op. So this needs to go to policy forward. That seems weird to me as well, though. Hang on. Is there Torch LSTM GitHub source? Look, so this is what I'm trying to figure out, folks. So in Torch, they obviously have C++ classes that they have exposed to Python that work with Torch compile. Their guides do not tell you how to do this one bit. So this is completely undocumented, and it's a complete mess, which is a bad combination. But what I think is going to happen is if we look here, they're not managing the weights here. You can see that there are not any weights declared. This is state, not weights. So Torch LSTM C++ source. Where is it? Test C API. I don't want to test. Okay, here it is. Yeah, this one. So here's their RNN in C++. Okay, cell params. Cell params. I have so much code devoted to quantization for this. Cell type. I'm looking for, okay, LSTM impl. What is this? Is this the Ford function? Simplifying dispatch. Okay, so here we see that they do have a version of this function, right, that takes all the parameters. So this is not just tied to a class. Oh, do they even have a class in here? Wait, maybe they don't have a class. Well, something has to manage the, something has to be managing these parameters though, right? Hmm. Okay, this is actually useful here. So, hmm. This bothers me like quite a bit that it is this way, but I think I think it is worth trying to figure this out. Um, just so we can compare it and use torch compile directly. Because like if I do coup de graph manually, right? Honestly, kind of tempted. It's probably doing the same thing under the hood, isn't it? Hang on, let me think about this clearly because CUDA only graphs which do not mutate inputs. Okay. Hmm. I have no idea what their default does. How's progress on Puffer 4? Welcome. So I have a prototype that works and is fast for vectorization. And now we're basically trying to figure out the CUDA launch overhead. I got up to 6.5, I believe 6.5 million steps per second. And the target is 10. Good chunk of it's CUDA overhead, so that's what we're looking at right now. Okay, so options. Let me just make sure I think through this because it seems like either way I do this, it's going to be a total pain. and I want to make sure I'm doing it sanely. So options are use torch compile or do coup de graphs manually. Torch compile will do coup de graphs for you. It also has a slower to compile mode that can potentially produce faster kernels. The annoyance with this is that torch compile is terribly designed. It's very often slower from what I've seen, and there's very little ability to figure out why. I can technically torch compile different chunks of the code the same way I can do coup de graphs to different chunks. It does also make me separate out stuff from the C++ a little bit more, but I probably am going to want to do that anyways, right? I'm going to want you to be able to use each segment. The alternative is what? So the alternative is that I just do coup de graphs myself manually. This will add quite a bit of code to the C++ that would have to be maintained. Don't have to deal with torch compile, but it'll also break my nets with torch compile. That doesn't seem good. It seems like, because if you want to be able to mix and match these ops, then they should work with torch compile, right? So it seems like that is probably what I need to do. And I think the only reason that this would be a bad idea is if I go and I do all of this and I profile and it doesn't actually get me the expected perf improvement. Savesh, welcome. Where did I see you? Long time. Okay, so I'll tell this real quick. So what happened is I was getting to be kind of burnt out anyways. I was going to take some time off. And then I got mice in the warehouse, and that was just not a bunch of fun. So I kind of said screw it on 48 hours notice, booked a flight to Hawaii, and yeah, I just was there for a week. And then I filtered my way back through, spent a couple more days in California on the way back, and went to visit some family as well in New England, and now I'm back in Florida for the middle of the winter at least. So that's where I've been. Manual coup de grace isolations. They do it in Python though, with this mark step, and it's absolutely disgusting, right? Wait, why is this under meta PyTorch? I didn't think this was under meta. Yeah, this is also not performance comparable with Puffer. Puffer is ludicrously faster than this. But let me see. I think that this chunk of code, this might be useful. So okay, so this chunk here is completely redundant if you just write stuff in C++. Yeah, so all of this is basically a negative in my mind. This is the thing I really need. Pretty fast for Python, but yeah, that's the thing. Fast for Python. The point of Python is it's supposed to be easy. So when your Python is literally harder to use and make sense of than if you just wrote it low level, you're just an idiot, right? And this is the problem with a lot of the stuff in RL right now, is it's core infrastructure that's written in Python for the sake of writing it in Python, and it's just completely brain dead. That's the problem. Actually, if all of this stuff were just written in C++, I would have no problems, or even like C or C++. And to be fair, the Torch C++ is really bad C++. So if this were written in like remotely decent of either C or C++, it would just be fine. Obviously, I'd prefer to be closer to pure C, but like just nothing exists at the moment. Basically, all these frameworks are either a mix of C++ and Python with too much stuff in Python, or they're pure Python, and in either case, the result is garbage. They do isolations I found interesting. If you point me to them. Ah, okay. So, I mean, given this, right, the fact that they're compiled adds overhead, doesn't this like mean that we should just do CUDA graphs manually? Highly educated, but also opinionated. Yeah, that's one of my favorite things ever to do. Is like, what is the MIT PhD's opinion on this? Well, that's fucking stupid. It's like, really? You couldn't give me a more nuanced or, interesting take than that? You couldn't? It's like, nope. Dumb is dumb. There was absolutely no reason to do it that way, and they did it anyways because they really like Python. I mean, there really is, there are no two ways about it in a lot of these cases. It's just people putting crap in Python that should not be in Python. And like, you don't get to just write the same code in Python versus C. I think people don't understand that, right? Like, there are a lot of times where you have to write more code in Python because there are performance optimizations that you have to introduce because you're writing in Python that would not exist if you were writing in C or C++. So like a lot of the time when you're doing this stuff, it's literally easier to just write it low level and call it a day. And faster. Well, we're not going to look at these numbers because all of these are super slow anyways. But I think that this chunk here, this is useful because I forgot about this, right? So this is why you get inconsistent speedups out of Torch compile. So I think we just go back to CUDA graphs, right? Something. What do you mean there's some little benefit? There isn't, dude. Reduce overhead does a bunch of checks and then calls CUDA graph. Those checks add extra overhead. And for some reason, they do it every iteration. Which is like, again, if they just did it on the first iteration, this all would be fine. Very poor design. And then this tensor dict, yeah, this is just going to be doing the exact same thing as I'm doing, which is calling all the transfers non-blocking and then synchronizing after you've initiated them all. Sweeping, does it run on its own? And then I'll get my own parameters. Yep, that's how it works. All the parameters just get tracked on Neptune and Wanby. You go look through your experiments. You decide what ones you want. You just copy them over for now. There's a utility in Puffer 4 that's going to make you be able to load them up in a visualizer and then just click on the data point you want to copy. But that's not there yet. Memory intensive speedups, not memory friendly. Yeah, that's CUDA graphs though, dude. Because CUDA graphs have to keep the buffers around, right? Well, this is annoying because, like, I was thinking, well, the way to do it would be to stick to the way that Torch is doing it and just expose my networks and stuff. But, I mean, with what I'm looking at here, that's not going to be enough. And I'm going to have to do this gross graphing stuff anyways, right? But then I also don't get the max auto-tune kernels, which is annoying. I'm trying to think about the trade-offs here. So, the thing I really, really did not like about Torch Compile, in addition to all the bugs and things that come from it, I really, really did not like that it adds so much startup time to your program. Because think about it, right? Like, I want the unit of compute for Puffer to become the sweep, right? I want you to be doing full sweeps. And adding a ton of startup time is really not great for that. I could technically go through and try to figure out why Torch is so slow and all that, but it's such a bloated library that it's really not even worth it. So the other thing I suppose is, so if I do CUDA graphs, presumably I could swap the backend at some point, right? Like if I wanted it to be not Torch for the backend. Create the cool graphs slowly. Torch compile backends. I know of default, reduce overhead, max autotune, and max autotune no CUDA graphs. I don't know any of those that would do that. From what I've seen, they're all just super slow, man. And I don't even think creating the graph... The thing is, I don't even think that creating the graph should be hard. Like, I think it's just because of Python, right? Because compile only does... Like, default compile does two things. You eliminate Python overhead, which you could just not write it in Python to begin with, so that's useless. And it runs CUDA graph. But running CUDA graph should just be like... that should be one forward pass. Like, am I wrong, or aren't CUDA graphs super quick to create? Like, here. How much overhead should be expected compared to the build CUDA graphs? They aren't quick to detect. What do you mean they aren't quick to detect? It's literally a trace. If you build them yourself, it should be fun. What do you mean if you, like, so there is literally, CUDA gives you the same trace API as Torch. Like, Torch is actually a pretty thin wrapper Well, not thin. They add a bunch of checks. Graph capture, graph instantiation. Roughly 1 forward pass is what I would expect. Hundreds of microseconds to milliseconds, this is nothing. Torch will wait to get a lot of traces to better understand things. Yeah, so I don't want it to do that, though. Because Torch will do that. The thing is, in RL, Torch will do that. It'll, like, spin for a minute, and then it'll give you code that's literally slower than eager mode. Like, most of the time. So what I'm thinking here, right, is I think that what we should do is we should just say compile can go away. We just drop compile, and we do CUDA graphs. Because the thing is, I was thinking we were going to do compile today, but I forgot that it's actually slower than using CUDA graphs native. I forgot they add a bunch of checks and things, and that you have to use additional... you have to just graph anyways, basically. Welcome, Son of Liberty. Merry Christmas. Today we're attempting to kill off the CUDA graph overhead with Puffer 4. See, this is why I need to stream, because otherwise I don't actually bother to talk through things out loud, and I miss stuff. Like, you see I was adding all this stuff here. So this was the other plan, right? Is that you compile, but you see how gross this is? Because, like, I don't want to trace this. This is all Python. If you do CUDA graphs, use Gumball sampling. Huh? For what? Use Gumball sampling for what, though? What does that mean? Now, you're more than rubber ducks. There are some people here that do RL. Is there like a built-in... Okay, Lance, this does not look like something that exists. I know what Gumball sampling is. I have no idea how it has anything to do with CUDA graphs. For action sampling. Oh, yeah, okay. That was something I was wanting to play with. That was something I wanted to play with. I mean, we're going to profile all of this as well, because we're going to actually see... The thing is, nobody has good profiles on stuff, so we're going to get good profiles to make sure actions are a bottleneck. Dumbbell softmax. Yeah, I'm familiar with that, man. But then you brought it up in the context of CUDA graph, so I was like, huh? There shouldn't be anything that needs sampling. It's done for RNG, right? Back and forth afterwards. The back and forth afterwards. That's what the C++ and CUDA graphs are for, though, yeah? We will have the fastest implementation. We should be... The goal is that we're pushing 10 mil plus for Puffer 4 before I ship it. 10 mil steps per second. Now, and I can do... I'm going to do all of my development locally. I actually now have a 5070, so I can profile a lower end system. but I cannot profile it on stream, otherwise it'll crash, like lag and crash the stream because it's on the same card. So I will do everything except that on stream. Yeah, this is what we needed right here. I don't know, from what I've seen from the profile, man, it's like there's just overhead everywhere. There's pretty much just overhead everywhere. Oops. Okay, so this number is not going to be 10 mil for reference here. Like, you're not going to ever see this number 10 mil because this is on... This is my new... I bought this desktop because it was a quick ship. So this is the 5070 machine. It's good enough for streaming. It's good enough for local development and whatever else. But, yeah, it's not like my 5090 machine. Multinomial is slow. I've tried a few different versions of that, man. It's actually kind of tough to make that fast from what I've seen. Though I have not tried... I think I have been profiling Python overhead with it. So I still have to try that in C++. Avoid softmax. What would you do different in computation graphs of Torch? Start working tensor library in C. And Vulkan. What? Vulkan rendering. Huh? It's pretty much just that Torch compile, they implemented it in Python for some reason. Like, Torch compile, it should have a C++ core with hooks into Python. Because, like, the thing is, you don't have to compile C++ code in the first place, right? You don't have to trace C++. It's already compiled code. But you still need to do CUDA graphs and stuff. And you do not have the ability to just use Torch for CUDA graphs from C++. You have to go through Python, and it's really, really difficult to move code across the C++ Python barrier with the way that Torch has their stuff set up, and it's even harder for compile. So it's just a massive pain, and then with all the overhead and checks that they add, like, it's literally slower than eager mode most of the time. And you have to do a whole bunch of black magic in order to actually make it work, and their error messages suck. If we avoid... You can't avoid softmax. What? You can't avoid softmax, dude, though. What are you talking about? How do you compute logic props? Oh, that Gumbel softmax sampling thing? Doesn't that change... Wait, does that change the output, though? So if we avoid Torch softmax, we avoid Torch multi... Yeah, because it's... I remember that, like, way, way long ago. When that thing came out. Okay. Where was my graphing stuff? Torch log. Yeah, I've done that before as well. I think that you still, like, the random noise still becomes the bottleneck then is the thing. I'll copy this for later, but... go time things. I think if you do that, you end up having, like, I did a whole bunch of stuff on that before, and it wasn't that helpful, if I recall. Like, it seemed like a perf win in the micro benchmarks, but then it actually wasn't. All right. Cool. What we're gonna do, let's get back to this. I believe I had running the coup de graph directly. So maybe if it's in that, can you trace RNG gen? No. We'll figure that out later. We have a whole bunch of stuff to do before that, man. There is CUDA launch overhead right now, and that's like independent, and I have profiled, and it is substantial. So either way, we need to do this. Okay, do I have this? What's this? Yeah, it looks like I was starting. Yeah, okay, so this is what I was starting. Pufferlib capture forward. So let's not do this. Let's do, can we do trace? I think we can do trace, right? The way that I want to do this, I don't want this to be like on first execution, right? This is the way PyTorch does it. I think that's really bad design. What I'd like to have is I would like to have it so when you instantiate the network, it also does one pass forward. You have to tell it the shapes, of course. But then it graphs it. So essentially you get your overhead on a NIT and not your overhead on the first few iterations, and then you don't break your profiling. I think this is the way forward. And I actually already have all the buffers, don't I? So I can't do create. Is it like create Pufferlib or something? I need to clean all this stuff up, but here it is. Okay, so yeah, it was something like this, right? Init coup de graph, capture forward. Welcome everyone from YouTube. Merry Christmas. I am back and will be doing quite a bit of streaming over the next several weeks. Attempting to finish 4.0. I'm going to say at a high level, the goals are going to be kill off CUDA overhead. That's a big one because that covers compile and graphing. It's going to be miscellaneous performance optimizations derived from micro benchmarks. So really good benchmarks. Clean up the code a whole bunch. Have numerical checks on everything so we can actually make sure that this is all done correctly. We have to find a replacement or a speed up for RMS norm. And that's like most of what is going to go into perf. And then the other side is going to be finishing up Constellation, which is mostly experimental work. just running tons and tons and tons of sweeps on all the ends and aggregating the results and fixing any problems along the way, and then cleaning up the new visualizer UI for release. That is most of what will go into 4.0. The goal for 4.0 should be that we have fast, we have pretty simple entry to the project, so it shouldn't really get dramatically more complicated despite all this new low-level stuff. And, well, I mean, 10 mil is going to be more than a double speed up from 3.0, plus all the new visualizations and stuff. And actually, I think it's going to be substantially faster than double, because, like, one of the reasons that I'm doing this, I'm not just doing all this work so that we can get double speed. There's an importance to reducing overhead in RL beyond just like max throughput speed, and that is that this will allow our hyperparameter sweep algorithm to find smaller batch solutions to a lot of the problems, which would not have been efficient to run before but are efficient now. So I think that we're going to see dramatic reduction in either samples or wall clock from this, like more so than you would expect naively from just the performance tests. And then we want to have a good understanding of how all these things trade off. I think that's going to be the goal. Okay, so we got coup de graph here. This does not seem like the correct type. It's this. Yeah, you probably just need this, right? Oh yeah, the one other thing I want to do for 4.0 is I want to get the puffer a makeover. He's gonna get himself. We're sending him to the spa. He's gonna get a nice massage. You know, he's gonna get whatever the hell else they do at spas. I don't know. And we're gonna get him nice streamlined, get him some new animations and some stuff. He's gonna look pretty much the same. He's not gonna like look dramatically different. It's just gonna be a little bit more polished. And then the thing is that the way that the model is created right now, it's not done in a way that makes it easy to rig animations. So we're gonna have stuff redone in a way where it can have a bunch of different animations and it can swim around and do other things. That's the goal with him. And it's just one little fun thing, right? I like the puffer. Tensor does not have a device. Tensor does not. Interesting. Okay. Stop device. Really? Oh, does this get, hang on, obs buff? I think that this is my bad, right? I think I do this here. Yeah, I don't pass any of this stuff in. I don't know why I don't. Yeah, see, like these are all created here. So where's this get set? Do we set this at some point? I don't remember setting it. Doesn't look like it. Great Pufferlib. Okay. This gets bound. And then we just do... Yeah, so this is why I had this here, right? Just have to do... So doing this. Observations. Actions. Yeah, there we go. Yes. Yeah, I think I've just made a big mess of this, and this just needs some time to be cleaned up is all right. Um, yeah, let's just do... Hmm. Five. We'll just... Here's what we'll do. This is no good. Here's what we're gonna do. I'm gonna just move this over. I think we can leave this for now. But we're gonna move towards the correct direction here. So we'll just do torch, tensor. observations, actions, log probs, rewards, terminals, applications, doesn't get used, terminals, ep lengths, ep indices. I don't think I used this, right? Yeah, I don't use this anymore. This is old. And then all I need to do is I keep env obs, actions, rewards, and terminals like this, right? This is cool? This is cool. Okay. And then in create Pufferlib, okay. And then we get segments, horizon, D type equals ob space dot D type. Actions. What's this? A pin memory. Some of these are going to be different, right? I think it's fine for now. What are we building? Currently, I am working on adding coup graph support in C++ to Pufferlib. And I have to restructure some stuff to do that. Okay, this does give you your buffers, though. Yeah, there's so many different ways you could do this, but it's like, I think this is going to be the correct one now. I'm quite confident. We'll see. I really don't like that I don't have kernel tuning as a result of this, but like realistically, I don't think I need it, and I think that this is going to be better anyways. Because like, why am I going to take a guaranteed big overhead hit and complexity hit for something that may or may not give you any performance? Init q.graph. And then capture forward. It's just obs buff. Oh, you need a state buffer, don't you? Let me go. One moment, Spencer. I was planning to do a big stream today, though I will be free later. Is tonight good? Oh yeah, since we have a lot of new folks probably here, go ahead and star the Puffer Discord, or star the Puffer Discord, star the Puffer repo if you don't mind. It really, really helps us out a lot, and you know, the more that the library just grows on its own from people watching the stream and people contributing code and stuff like that, the more time I get to spend developing, and the less time I have to spend on promo and other stuff like that. I do work on this at least full time. I don't know, do you say you work on something full time when realistically it's much more than full time? Though, admittedly, I say I've been lazy the last couple weeks, but that's kind of the point of taking a vacation, isn't it? Foreign concept. Hey, I did get the C vectorization done over vacation, alright? I did get the CVec to work. Oh yeah, I'm just gonna need a ton of these buffers, right? This. Check these shapes. I may as well capture the sampling as well, right? We'll do env. We'll do env logits for now. And then this is 3. Right? I'm just trying to set up the graph capture thing cleanly, and it's a little awkward if you're not used to it because it requires you to have all these static tensor shapes, which, like, if you just retrofit that onto an existing code base, it's going to make a mess. But you can actually end up having it look pretty clean, I'm quite sure. We just have to figure out how we're going to do it. This can go down here. State. And this should not be horizon either, right? Batch size. What am I trying to do? I'm trying to get CUDA graphs in native C++. So the idea of this, right, is I have the whole training code now in C++, so there's no Python overhead, but there is still CUDA launch overhead. And that is what graph is going to do. It's going to capture all those operations and then merge them all together. I guess technically, Now, you still really wouldn't want to, I guess like the sort of the next best thing you would do is what LeanRL does, where you keep stuff in Python, but you have it graphed, because that would still be one operation. But like, that's still too many loops in Python, I'm pretty sure. I mean, also, it's just like, yeah, I think this is gonna just be better. Python just causes so many problems, and realistically, you don't even get that much from doing it. Like, I'm trying to think what is Python, like, what is Python specific that I want to use, and I'm coming up blank. It's just the fact that the Torch C++ API is kind of crappy. I guess I'll be able to play with it though. Once I have this as the baseline, I'll be able to see like, okay, if I just do the graphing in Python, like how close do I get in performance? How close do I get in startup time? I think this is the best possible thing I can do though, so we should do this first before we try to do anything else. Yeah, that'll be it. Oh, right, so this is for the graph. So what this is supposed to do, do I not save this graph? Void CUDA graph. Pufferlib CUDA graph equals, yeah, no, this is saved. So, yeah, this is the chunk right here, right? This, like this chunk, where you just do replay graph. Which is this right here, right? This. So yeah, if we are able to do this, I mean, this is going to take me some time today, for sure. Should just be this, right? Initial state. Oh, it's policy initial state, right? Hey, 20, welcome. Star Pufferlib. Huh? Auto. This is... I'm confused. Isn't this is the pointer? Right? Pufferlib. Capture forward. Init graph. Oh, Pufferlib dot get. Weird C++ shenanigans. I honestly think that once this is cleaned up, we can make this whole thing no more complicated than the Python. In some places, arguably simpler. std make unique. Return Pufferlib. Okay, so it's just got to be .get. So it's Pufferlib opt.get. Try this. One day we will just have a nice TensorC API that actually works. One day. How am I doing this wrong? Oh, because it's a shared. High school in grade 8. Honestly, the math is going to take you a while, man. It's not that math heavy of a domain, but you do need to at least have some reasonable understanding of linear algebra and multivariate calculus, as applied to matrices and tensors, which if you're smart but not a total genius, will be end of high school, start of college. The thing that you can do that's a lot more accessible but just takes a ton of time is to get good programming fundamentals in, because most people Most people in AI are suffering from lack of being able to program appropriately more than anything else. And it's much easier to get into because you do not have, like, you don't need any required math background in order to start. I have on my X, there's an article that's my guide for programming in ML. That has some very good pointers because the reason programming is hard is it's one of the worst taught subjects. It's really, really badly taught. The way that it's usually taught in school will actually pretty much guarantee that you will be a terrible programmer for the next decade. So I'd take a look at some of the advice I have there and start building some small projects and really trying to just do stuff in the simplest way possible and build up to more and more complex things while trying to keep the way that you're building things very simple. Yeah, the articles are going to put it better than I do. That's why I wrote them, is so I don't have to come up with an impromptu, eloquent explanation on stream, right? It's all in those articles. Yeah, just do this. What's this say? It's a problem. Is this? I don't understand how this is not already a pointer. You're good. The reason I stream is so people can ask stuff. But yeah, getting to be a good programmer is very hard. It just takes a lot of time, and most of the resources out there are very bad. So my guide will cover it, but like starting out with Python is going to be the least frustrating thing, but then very early on you want to learn some low-level dev. And if you do it right, it should not be a frustrating mess. It should feel very natural and easy. The problem is that most ways that it's introduced make it feel very frustrating. Push library and share, like PyTorch with a bunch of operators and activators. I mean, I'm pretty sure, man, if TinyGrad had just written their stuff in C, it would be very close. For instance. The fact that TinyGrad decided to do pure Python, though, is like, I get why they do it, but it really limits you a lot. It's just really limiting. I think we're still going to end up using chunks of their stuff, though, for kernels. I have to get back to doing that at some point, but this needs to be done first, you know? I was very pleasantly surprised by some of their stuff, though. Yeah. I would prefer C, frankly. C++ simply does not bring joy. There's really nothing in C++ that I ever want. And there are many, many things in C++ that just make life a complete living hell. So, I don't know, to me, like, the zen of low-level programming is that there are very few tools, you learn how to use them, there's not an never-ending supply of new things, and with this very small set of tools, you can just make things that are fast and simple, and that are much more robust than pretty much any other modern software, any modern software at all. Okay, cool. Construct, a bunch of operators and tests. Yeah, so you need. So what do you need in a tensor library? Honestly, you need a good tensor struct, like an actually good tensor struct. You need to have a good way of setting up kernels. You need like a simple and good autograd. And you do need coup de graph support, though that can be introduced later. You will need coup de graph support. Nice extras include like little profiling tools and things. Those are nice to have. But ultimately, yeah, I think a good tensor library could be, well, I mean, tinygrad has what, 18,000 lines? And I think that they already had reasonable stuff when it was below 10,000. We can probably get the basics done in less than 5. Statement of purpose layout. I decided to apply for a PhD, studied for and took the GRE, and wrote my statements in the span of 2 weeks. So I'm probably not the best person to ask for that. I mean, I didn't have a layout, right? I wrote about my research is what I did. I wrote about all the research I did. I wrote about all the research that I wanted to do. It was so much easier for me to do that than it was for like undergrad applications. Those were just miserable. Meta AI. So Meta AI, they use Pufferlib, and I try to support them best I can. The structure of their project, it's gotten quite big, so I do my best to support them in a lot of places, but it's gotten big enough where it's very difficult for me to like actively support as much as I used to. Um, like for instance, I'm definitely going to help them integrate Puffer 4 when I have that, right? So like they get all the new perf benefits. But until then, it's kind of tricky for me to help them very much. Because I think like most of the problems that they have at the moment are just with the environment being slow. And the size of the environment code base and the structure of it are such that it's very difficult for me to help with that. But Meta AI and Puffer are like completely independent companies. Like Puffer is my company, Meta is not my company. Hi Jess, welcome. Good to see you. I've heard the chess stuff is looking really awesome. Merry Christmas as well. Yeah, I think Rick, Meta AI, that stuff will be very nice if they get it to be clean and fast. I'm going to do the best I can to help them with that, but they are also going to have to do quite a bit of cleanup work. Like, and speed is so important in RL, and it's really not that difficult to get right, but you have to, there's certain ways that you have to do things to get things to be as fast as they need to be. Buffer 4, yeah, it is, Rick, among other things. Looking at square, get to grasp program flow, C reset. Eric, like it's so when you call vec reset from Python, it just calls reset on every env. So like you don't even need a video because there is not any code defining program flow at all. Like there's not a big blob of code that you'd have to read through and understand. It's all very, very succinct. C reset gets called once, then it's just step, 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 and then the individual environments will reset themselves. Like they'll call reset on themselves inside of step when it needs to be. And that's actually in the squared example already for you. No, Jess, I got the multi-threading to work over vacation. I'm working on CUDA graphs right now. Having Python bindings for C, right? All the kernels. Do you have Python binding for C library? Right, well, the kernels have to be written in C, right? Um, a C library should be designed so that you can use it in C, and then the bindings allow you to also use it in Python. So you should not ever be designing a library. Like, a library should be designed so that it works with both languages, right? You should never be designing a low-level project with the idea that it's only ever going to be used from a high-level language. Okay, what did I do here? Oh, I forgot to add a couple params. Segments horizon. Yeah. Like the ideal case, right, is you want to minimize the pain of bringing code across the language border between C and whatever high-level language, but then you don't want to have to structure the low-level code in a way that it's harder to use from that language, from the low-level language, right? That's the balance you're trying to strike. Stream doesn't show a lot of coding agents. More productive? Yes, that just wastes my time, man. All the models are very, very bad at programming. You'll see that I don't use them much. Or actually, I really don't use them at all. I mainly just I've got essentially what's a fuzzy LSP. It's a really, really dumb, fast model. Doesn't do much more than an LSP. And then I use whatever model for docs. Why do you say most researchers are bad at programming? Because I've read a lot of researchers' code. They're terrible programmers. Almost without exception. There are a handful of good ones. I mean, I'm not going to tell you that big tech engineers are good programmers either. They're mostly terrible programmers too. Like, being good at programming is hard, and there are very, very few programmers that are actually good in general. I mean, to give you an idea, I feel like barely competent enough most of the time to get done the stuff that I need to get done. And like from my perspective, it's like everybody else is just running around on fire, like next to a pool, refusing to jump into it. It's just insane. It's completely insane. Fuzzy LSP? Anything right now? Well, it's just Super Maven, man. Look. Like, you see I have tab complete, but I don't have cursor for tab complete, right? I don't have like one of the actually good models, but you see it's instantaneous, right? Like as soon as I hit enter, I have a tab complete available. So the model is very stupid, but it's very fast. The idea is that it saves typing, not thinking. And that's really all I want, is I want something that saves typing, not thinking. Like, I want to think more, right? And I want to work less with things that are poorly designed, that people are incentivized to offload to a language model because they don't make any sense, right? Like, we should actually put in work to make things simple and intuitive and nice to use, such that you can reason about them yourself, rather than making things that don't make any sense, so that like only language models are willing to put up with them, right? Like one of these leads us to building better stuff that we understand that we can improve over time, and the other leads to a complete lack of control over anything we're building and just like enshittification of everything. Imposter. Well, this is not imposter syndrome, man. This is not like I feel like there are people out there that are like way more capable or whatever. I've never had that, right? I feel like this stuff is hard. I'm barely competent enough to do it, but I can make consistent progress. And I see a lot of people that are like absolutely not competent enough to do anything and create more problems than they solve. Yeah, that's Jess is totally correct on that. It's actually way more common in CS that people think they're good and just suck. Bad software design through generative code. Yeah, don't do that, Rick. It's not fun. It will make you hate your job. You will not learn anything. State. How on earth can the state be wrong? State must be num layers, batch, hidden size. Can I just get this from initial state? Oh, yeah. Wait. Huh? No, man, and the tools suck. They're selling a vision that like lazy, worthless people can be competent without putting in any work. It's a lie. They're trying to sell you something. See my albums and family relib. Jess, that's a totally reasonable thing to leave into the main.c file and not in the h file, right? Like, just leave that in for the C mode debugging. That's totally good to have. Yeah, but like like, I literally could not work that way, where it's just like, you have something writing a bunch of like that's you basically that is fixing garbage code as a job. If I wanted to fix garbage code as a job, I'd go work in big tech. And it's actually one of the unique things about doing my own thing here is that I actually get to have full control over everything, and I get to make sure stuff is good. What's happened here? Why? 44096. Want to get into RL? No Python, basic math, high school student, want to study university in the US, and work in ML in the future. That's pretty much where I started off, man. I have my guides on X. These have all of my best advice in one place. I would start with this one. This, like, if you actually really, really read this and listen to the advice here, this will save you a tremendous amount of, like, wasted time. Like, really, everything in here, you might just glance over it, but, like, everything in here is basically a very hard-won lesson from wasting a lot of time. So I would read this, probably read this multiple times over the next few months, as you're learning more stuff. And then for RL specifically, I have this one if you're interested. RL's kind of cool because you end up learning low-level dev in the process with all the puffer stuff these days, and you're also doing some ML. If you're interested in more generic ML, though, like CS231N is a good place to start, and that's in the guide as well. Gotten offers from VC. I mean, I'd have to actually take meetings on the basis of trying to get funding to get offers. But I get a lot of messages from VCs interested in investing, and I'm not raising. Why would I raise? Like, Puffer is profitable. Okay, this is not how this works, right? Yeah, this is not how this works. How the hell does this work in C++? Yeah, this is the most LLM usage you will see me do. I do have a product. We build custom simulations for companies. And we train high-performance RL agents on them by integrating with Puffer. We have several active contracts. What graphics card did you use? We have, it's mostly 4090s. Okay, we'll put this for now. Stupid thing. Yeah, we'll put this in here for now. I don't like this, I don't like the way that this macro works either. I see it as more of a service. All right, so Liberty, think of it this way. If Pufferlib were closed source, this would be like a really obvious thing that you could pay for and buy, right? Like, you like even if it's third party free use behind an API or whatever, or if it's just like a binary, then it would make sense to have a simulation development service or research services or whatever. Okay, so you get the result of that, except it's also closed source, so you're no longer behind a third party API wall. There's the value. I'm going to read multiple times. Genuinely interested in it. US is doing a great job. Thank you. Yeah, I would, especially like the bits on keeping stuff simple and not getting sidetracked by all the fancy things, and like on how to view science and research as a whole. I mean, the thing that's difficult is it's going to take you many years before you can actually tell which chunks of stuff are bullshit and which chunks of stuff are not. But just knowing that there is a lot of it out there is very important, because otherwise, like, you'll be banging your head against something, wondering why something doesn't make sense, when a lot of the time it's because it just genuinely doesn't make sense. Yeah. Let's do this for now, just to like check this. I think at 12 I'm going to take a quick break and get some more tea, restroom, walk around a bit. And as I say as well, Liberty, it's like making money is not the first objective of Puffer, but it is the second objective, if that makes sense. And now objective number 1 is fix this field, put RL on the map, make this awesome tech exist and be broadly available. Objective number 2 is throw it on a whole bunch of useful applications, and that should be profitable. Why do we get a different error? How did we get a different error? That is so weird. Type int. Oh, I see. Do we? See you, Rick. Yeah. And I mean, a decent chunk of the money, like the goal with the profit is like personal gain. But then also, if this does well, then that allows me to fund more research efforts, right, in related areas. I try to be 20. I try to be. Oh, torch check fail. Okay, I see. Why didn't it print? Seeding, like fruit. It'll be seeded by default in C, man. Pretty sure. Hey, Anas, welcome. I think it is, actually. I don't know. I actually don't know how that works. I don't know if in C it's deterministic unless you specify a time-based seed. I'm pretty sure it is. Whatever. This check is a mess anyways. Let's just do this for now. So I want to get this before I break for noon. Only quick break as well. Oh, huh. That's kind of weird, isn't it? Thought there were 2 buffers. Okay. Oh, you know why? Okay, it's because it gets indexed. I'm dumb. Yeah, it's because it gets indexed. I'm dumb. I forgot you declare the state for all m's. Graphs must be captured. Okay, so this is me not understanding API. Grok should be... I don't know if Grok is smart enough for this. Okay, so non-default stream. You just set like this. What's your setup? No, because I said if anybody I respected replied with like a reasonable setup, and mostly the people who I know who are pretty good told me like, yeah, this isn't actually going to help you, and I got a bunch of batshit insane people telling me stuff that made no sense. So, unless anybody is going to give me something to the contrary, I'm mostly still assuming that this is just imbeciles who have been convinced by LLMs that they now know how to program when they have absolutely no idea what they're doing. Welcome, Robin. Like, this is, I consider this using this for docs, right? Like, this is me not knowing what is the function to get and set the default, or get and set the current stream, right? This is not me asking, how do I implement a piece of logic? Okay, on tokens. Yeah. Yeah, Jess, the thing is the puffer core is going to change so much in 4.0. Like, let me focus on getting this thing nice and compact first. Because if I were to do this right now on 4.0, it'd be like, don't look at that. This code sucks. This code sucks. This code sucks. This code's pretty good. This code's really good. This code sucks. Yada yada. Um, like the stuff you see me writing here is not the final state of it. Most of this is a mess. Okay, what happened here? So presumably these are bad shapes. Ah, I see. So we're gonna have to, like, the thing is that this forward pass, it actually writes to different indices. And to inaugurate the release of Puffer 4. I need to go find myself like a good, it would be like a 3D animation and character artist, I suppose. Somebody who's done low poly style stuff. Because I want to get the puffer, I want to get the puffer tuned up a little bit. Go Explorer will probably be pretty good for chess, Jess, but it'll be way better for very long form games. Yeah, so like that is one of the things that Go Explorer helps with, but it'll be way more helpful for games with a million horizon, right? Or whatever. Hmm. Pufferlib? Because puffer. The puffer fish. I mean, look, I could come up with some ridiculous name for all the complicated stuff we do, but there's not really any way to pick a name that describes all this stuff, so here, have a puffer fish. See? It puffs up. Okay, I'm gonna have to figure out, because the thing is there are a couple errors here, but we also have to figure out how to trace this. We have to trace... Actually, probably the easiest thing will just be to trace both executions, right? Trace like both buffers worth of ops. Ooh, no, I can't do that. Okay, I'm gonna have to figure this out then. Alright, I'm gonna go. It's just about 12. I'm gonna take a quick break. I'm gonna go get myself another big mug of tea, use the restroom, walk around for a bit. I'll be back as quick as I can. Might be 10 minutes. Might be 10-ish minutes if I'm quick. And then we're gonna see, the goal for today is to get CUDA graphs to work. If we can get CUDA graphs to work and get an initial profile today, I will be happy. Because I think this is the last major unknown technical thing. We shall see. I will be back. Oh, if you're new around here and you haven't already, please just star the GitHub repo. It's Pufferlib on GitHub. That really, really helps me out. It's free. And other than that, yeah, excuse me. Where is my phone? Okay, just gotta get myself a new mug of tea, and I'll be right back. Okay. Hello. Code error. Fucking optimizing Mario Kart. Cool. This is optimizing coup de graph pane. I mean, this really does just feel like fighting ignorance in some sense, because it's always the case that the easy way to do stuff, like the way that it's designed, the way that libraries are designed for you to use them, they make it really easy to do stuff the wrong way and really, really hard to do stuff the right way. Okay, so need a stream to watch an Opus. Nah, you don't need Opus, man. You need to make stuff simple. Thank you, Anish. It was nice. And of course, the first day I'm back, I remember why I needed the vacation dealing with this crap. And no wonder I was tired. Alright, so we got... Okay, so we can figure this thing out first. Gem and bias error. Transpose mat 1 to 0. MNK. This looks like correct shapes to me, no? You get the full error. Padding views. Hey, Quinn. Yeah, I took a vacation. Much needed. Here's the bug. Okay, so we get the error here. It's contiguous and stay contiguous. Okay, so the inputs are contiguous now. Watch Pantheon? No, what's that? I don't really watch TV or movies. Why use Grok? It's built in and it's fast. It's very stupid though, I will say. I honestly think Grok 4 is worse than Grok 3. It's like really stupid. But I'm only trying to, I just need a model for fuzzy docs. So most of the time it's fine. I'm not actually using it to write code. I write the code. Just do this. Mind upload. Oh man, I think the only good sci-fi, like the only sci-fi series I've actually enjoyed is the Culture series. Like most sci-fi is so egregiously bad. My main forms of entertainment, right? Like I don't really watch TV or movies much. I listen to books and I play games. And when I listen to books, it's mostly fantasy because you'd think, oh yeah, sci-fi, what about that? But it's mostly just so egregiously bad. Okay, so this should give us a new error. Okay. So this is same error. Samples. Two-layer neural net, grateful, really enjoying learning ML. Welcome. Yeah, the CS231N will have you do that. You definitely want to understand the concept of autograd and like per layer gradients. Because if you try to naively do like backprop through the whole net at once, you're not going to have a fun time. Sam Altman tweeted how good that is not an Anthropic code. You're not selling it very well. You're not selling it very well there at all, man. Both those dudes are fucking nuts. Okay, so this thing is dumb. Let's get rid of this. We'll try dish. I'm gonna paste the exact same error. Tiny torch is awesome. Yeah, that's very good. How do you read this? Look at these terminal fonts. This one? Man, I made this. This is like my personal theme. Might as well bleed if you just put it on a white background. I mean, this is just like off black, slight cyan background with cyan, white, and red like font. You can go try it out if you want. The config for this is in Puffer Tank. Warm-up needs to happen on the same stream. Okay. Welcome, chicken. Merry Christmas. I think the capture stream, not the default. Okay, let me try this. So, stream synchronize. Just do an additional synchronize. Non-default stream for capture. Device guard, graph. Okay. See if this does anything different. Why can I not see? Oops. Oh my gosh, what the hell is that? If you type twitch.tc, it takes you to a spam site. Huh. Yo, Twitch, what are you doing? That's weird. And log in. Yeah, I'm live and I have no idea why it's doing this. I think it's just Twitch. It was fine earlier today. It's got it's got this stuff here. Error 1000. DNS. Oh, okay. It's the bitrate. Hang on, let me see. Hopefully this doesn't restart the stream, but I gotta fix my bitrate. Does it let me do that without restarting? No, it doesn't. We'll let that, I'll do that after then. It'll just, well, oh no, wait, it does. Hang on. 6,000 kbps, apply. Okay. We'll see if that fixes it. Okay, well that may or may not get applied. We'll see if it fixes itself in a bit. What do you recommend after CS231N? Autograph something that automates. Should I expect things to get easier? Yes, obviously things will get easier. This explains to you how things actually work, so you're not blindly treating PyTorch as a black box. Honestly, what I did is like, I read papers, I implemented papers, I did projects, I did my own research, right? It depends if you're interested in general ML or RL, right? Like with RL, we have tons of stuff around Pufferlib, and I have extensive guides for that. For ML, like, what are you interested in? Go do something in that area. As long as your interest is not training the biggest possible language model, because then I hope you have a quite large budget. Is this the same error? The same error. Make sure. Change something on OBS and restart it. Yeah, I don't want to restart the stream for that because maybe I can just restart the Twitch stream. Hang on. I think this will let me just restart Twitch. Yeah, there we go. Cool. Fixed. Thank you for that. Very dopamine intensive, man. With all the stuff I saw on, with all the tweets I saw from the frickin' RuneScape guys on X for Christmas, it took so much self-control to not download that again. Like that game is just straight heroin. Yeah, Twitch should work now. But RL is not yet fixed. I get to play more games when RL is fixed. I did download WoW over vacation, but by comparison, that's like not remotely close. Okay, so this is the exact same error. Let me see what we can do about this. So device guard. You warm up. More iterations. I highly doubt that changes anything, but we'll try it. It should just need one. Great RL, RS bots. Yeah, except that I'm not gonna go break my favorite game, man. Like, I'm not gonna go ruin my favorite game with more bots. I'm pretty sure that is the game that I have the most number of hours in. NB Chad. What? Okay, yeah, so this does not do anything. Allow pool allocations. Let me see what this is. Capture begin. Let me see what this does. Why Sonnet? I'm using fuzzy docs. Okay, I just need docs. Like, I don't want it to write any real code. Like, I basically just need something to tell me how to set up coup de grace correctly. Any model that does not have me waiting for minutes between calls is cool. Nitrogen? Teh. It doesn't even run real time, man. They apparently they like sped it up for the demo. Or like they removed all the pauses or whatever. I don't know. Like NVIDIA is cool, but I kind of just ignore everything from Jim Fan. Opus is faster. Oh, cool. I don't even have a subscription though. I don't really feel like getting one either. I don't really feel like supporting either of those. The thing is, I don't actually like use. It was weird. I don't know what happened because the latest Grok update made it super, super dumb. It was actually pretty much fine before. I mean, to be fair though, like this is a test because so far this is still pretty dumb as well. Did I remember to recompile? This is why I have to not pay so much attention to chat. I think I did though. So I think this is some completely different error, right? Yeah, there's got to be a completely different error. Internal status error. Oops. Give us a real error? No. Torch use CUDA DSA. Merry Christmas, Convert. Okay, so Self-driving and camera input. So it depends what layer you're simulating, right? The idea is they have some real data, but like you can do pretty much the whole planning part in sim. Like multiple real driving companies are using the Puffer Drive sim now. You basically need way, way, way less human data if you have a fast sim for training. Wait, this is already gonna fail. CUDA check implementation. Where would the real data come in the well, there are multiple ways you can do it, right? So one is mapping vision to state, like in an encoder type thing. Like obviously that you either have to do state estimation or you do it end to end, but like either way you can still use the fast sim for planning. Like there are a lot of situations there are a lot of edge cases and situations where you just need a ton of human data to get that you can easily just do in sim. And then really the only difference between the sim and the real world, if the sim is at least somewhat decent, is the input modality. So that can be done separately, right? Have a separate embedding model. You can go ask some of the NYU guys, because I don't know to what extent like information is public, but the project itself is open source. Mm-hmm. The heck? Let me see what the heck this is. It just wrote so much stuff. Blah 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 blah. But I think it errors before this, doesn't it? I think it errors before this, so this doesn't work. This, right? Well, let me try this, but I'm pretty sure maybe it does on second iteration or something. We shall see. Does this give us anything? No, it doesn't give us anything. And the reason it doesn't give us anything is because the error happens right here. Okay. Error happens right there. Oh, I see. Hey, Tim. Yes, thank you. There is Puffer Drive. Yeah, so Puffer Drive is the whole code base, man. It's all open source. And they just have, well, I don't know if it's actually been done yet officially, but there is a big release if you give it a couple days. It's all there already, though. But, there will be a lot of material that you can read quite soon. Okay, so can we do this one? I don't see how this does anything, though, because, like, cadence or synopsis, low-level logical sims. I don't know. I actually don't know what either of those companies do, but so the professional side of Puffer is we build high performance simulations for companies, and then we integrate them with Puffer's open source tools. So like all of our general stuff, like it's all open source. It's not open core. It's full open source. But then we build custom sims for companies in a variety of areas. You'd be surprised the amount of different stuff you can do. Like the environments that we have are actually very good benchmarks of whether stuff works or not. Okay, so it fails in well, this is completely brain dead. So far it's like, oh yeah, Grok's really stupid, but this is actually pretty stupid too. PyTorch is reallocating tensors. No, it's which lab would you pay sub for? I mean, I already have Grok. Like I'll get stuff if it's dramatically better, but Elliot, my experience has thus far been that all the models are really stupid, and it's like mostly just bad devs fighting over like basically leapfrogging or hopping to new models every couple months whenever the labs release a new one. Like the models are all just really dumb. Like this is like a one-line bug somewhere here. It is probably this, I would think, right? See, this is flailing. Disable to not use workspace allocations. Yeah, but you can't do this. This is stupid. Yeah, this is very, very stupid. I don't know, Elliot. I might go get Gemini or something eventually, but man. Loose cases, low-level logical sims, kids, chip design. Yeah, if they're fast, if the sims are fast or can be made fast, then absolutely. We had initial discussions with at least like one similar company um, a while ago, like before Puffer was anywhere as good as it is now. Not for LMs, but not for our ideally RL. Yeah. The thing is, like, the sims have to be fast. That's the main requirement for RL. And, like, it's not like your sim has to be fast now, but we have to be able to do the napkin math and say, oh, yeah, I can make a fast sim for you, right? And right now, it's ideally you want the sim to be fast without a ton of hardware. That will change in the future as Puffer gets more stable. Like, because the experiment outcomes will become much more consistent and predictable. But for now, it's like fast sim problems. But I'm not trying to get. The thing is, I'm not trying to get it to write me code. Like, you see it's outputting this whole thing, but I need one line of this. Like, I literally just need to figure out what is this graph capture error, or why can't I get a full trace? Can it be robust? Logic rules. Yes, because the thing is, the logic part is done by the sim, right? The agent just takes actions on the sim. Those actions can be validated by the sim itself. So it's not fuzzy in that sense. Hocus pocus. Hocus opus. Do I even have that? It's a submodel, man. I mean, I could go get one of the other ones, but like, this is literally docs. This is knowledge retrieval. This is not even something that should have to be thought about. Can I do this? I think this is a device side. Why is this inside of a... Hang on. Where's the print? Does it actually let you get to the catch, or is it doing something weird? Current limitations of Pufferlib? Well, as of 3.0, right, it's just like we're hitting all of the performance limitations of Torch itself. Like, Torch just doesn't let us go as fast as we want to from their Python API. we're getting limited by kernel fusions, we're getting limited by launch overhead, we're getting limited by compile overhead, we're getting limited by inability to profile, we're getting limited by like some specifics of the architecture we were using. It's kind of, they're just limitations everywhere. And in Puffer 4, the goal is that we actually have stuff done low level, low overhead, with accurate monitoring of actually where we are spending each chunk of our compute. We get 10 million steps per second. And that helps us quite a bit. Like, that will allow us to run a ton of experiments. We definitely need better tools for running not thousands, but like tens or hundreds of thousands of experiments. We have those now, and we have a beta version of Constellation, which is going to be the new visualization dashboard. So this should get us a ton of good insights. Now, there are still some core algorithmic limitations that we have to address, but those are going to be much easier to address once we have just higher confidence in general in the field. So Puffer 3 was much higher confidence, I would say, than Puffer 2. Like, when we use Puffer 3 for something, we understand the problem better, we have a better way of solving and approaching things, there's less fiddling. So Puffer 4 is similarly, there's going to be higher confidence, less fiddliness about it on new problems than in Puffer 3, and much faster. There's a crown near my name now? I don't know what that is. I didn't do anything. Operation failed due to a previous error during capture. Okay, so this annoys me because... Oh wait, no, it did print. Look. It did print. But it printed the same thing. Did it? Yeah, it printed the same thing. Warning. Oh, what? Here it is. I mean, I tried Grok, whatever it is, latest Grok, I've tried this. This is not a model problem, man. This is a docs problem. This is not logic, this is knowledge. Does Carpathy... Man, Carpathy is usually good, but he has some also very questionable stuff. Very smart guy. This is so weird that he does this. I mean, like, I can't possibly disagree with this more. Like, I have not seen a singular good dev produce something like genuinely good with all of these fancy tools. And Carpathy has produced several things that are genuinely good without these tools. So I just like this doesn't make sense to me. I feel the exact opposite. I feel like everybody else is mostly wasting their time, spinning their wheels, refusing to actually learn anything deeply, and just hoping that AI will think for them. It's extremely frustrating, really. And like, I mean, the proof of this, right, is if the portions of as a programmer, if your contributions are becoming increasingly sparse, that's not you becoming a better programmer, right? That's just you losing all of your value. That is you having zero additional value whatsoever. I mean, he coined the term vibe coding, right? And it's a complete disaster. I don't know. It really feels just like a bunch of lazy idiots have infested the field more than it does anything else. I mean, I'll reconsider when somebody shows me something genuinely good, but every single time somebody like claims to have something really good that they vibe coded up or whatever, even if they're an experienced engineer, it ends up being completely wrong. I've seen this happen many, many times. Because the thing is, like, programmers are not the most social type. All right, we're not very good at telling when people are lying to us. And the one thing that LLMs are superhuman at is lying. They just lie their asses off. They're very good at convincing you of bullshit. Like, see, this model here, it literally does not understand an if statement. And these are supposed to be superhuman. It doesn't understand that the error, right, is happening here, and that means this doesn't get executed. But yeah. They don't even run the test. They just pretend that they do, and then they lie. It's I don't know. To some extent, these models they feel architecturally stupid. You shouldn't need any of this shit. It should just be get last error. Let me see what's up here. So message, no error, code 0. Operation failed due to a... Okay, so this is very weird. What even is this? Heh. Let's get rid of this model. It's dumb. Okay, debug. See, this is not it. Go to check implementation. And what do we have here? Copy device to device. Are these not CUDA temps? Hang on. Did I not make these on CUDA? Op state. No, these are CUDA tensors. Right? These are both CUDA tensors. Yeah, but like the thing is, okay, if these things are superhuman on benchmarks and then they're completely useless on relatively simple tasks elsewhere, like you just have very shitty benchmarks that you're hacking. Like we've seen the same thing in RL. It really feels like LLM bros are just managing to repeat the worst era of RL research, but now we're burning billions of dollars. Yes, Liberty, but it's dramatically more of a pain in the ass to set all that stuff up with something like this than it is with a pure Python program. There's like actually a pretty sophisticated stack of stuff here. It's cool that RL is being used on language models, but like RL is useful completely independently of language models. Like we can decide that we actually don't need to RL language models tomorrow, and there will still be plenty of useful things to do with RL. Developed it. See, taste itself is like a bullshit ass concept as well. There isn't like there's not a thing of taste. It's not subjective. It's like there are regions that are subjective, but the vast majority of things are just objectively stupid. It's not like the person that was developing this library had poor taste, so it's bad. It's the person who was developing this was a shit programmer, so it's bad. It's like actually quite simple. Concise is a good one. There should be a strong bias towards simplicity. There should be a strong bias to using fewer things well rather than many things poorly. Um, there should be a recognition of performance targets for what you are building and what is needed for them. Next 5, 10. So in RL, I think the longer term, which 5 or 10 is longer term at this point, is biological sim and material science, like getting this stuff into not just like query the LLM, please solve cancer for us, but can we build high performance sims and use them substantially, like for substantial parts, right, of research. LSTM's a better core. LSTMs are a better core than not having LSTMs for RL, like not having any sort of memory. We're currently messing around with Mingru. Mingru is likely to be the core of our next architecture here. Yeah, Robin, that's kind of what I feel like as well. It's basically just like people who have absolutely no skill or value whatsoever attempting to ascribe themselves some value in the use of tools that they don't understand and did not build. I mean, I consider myself quite arrogant, and that's just like a completely different level of arrogance, right? That's just like off the charts delusional. Like, the type of arrogance I have is I don't know what I'm doing half the time, but I know I'm at least in a better position to figure it out than virtually anybody else, right? This is so irritating. Why compile with this? CUDA error, stream capture invalidated. I mean, this, I looked at this page, right? Did I not see this? Get something out of like Stack Overflow. Why does this work this way? COVID to learn CUDA. Well, for anybody new around here, I do like to mention, if you want to help me out for absolutely free, just start the repo. Feed the puffer a star. Look, I literally made an RL environment about puffers eating stars. That's gotta get you to start the repo, right? No. I don't like being stuck on dumb things like this. I'm stuck here because I don't have a proper error message, and I don't understand why I can't get a proper error message. Right, because this doesn't run, so CUDA get error string doesn't run. If you run it here, it says it's empty. But how is there a previous? Well, of course, it's because of the graphing, right? Can I see? Maybe I can see this. Okay, so this is here, right? Like, this is literally the first layer. Encoder forward observations, right? So it's breaking on. How can it be breaking on the first layer? With graphing on. I mean, it must be like set graphs up wrong, right? Like, CUDA graph. Actually, is there an example? PyTorch CUDA graph C++? Capture must occur on a non-default stream. This, I could be doing this wrong, right? Because this is probably the default stream. You know, I just need like a little sample bit. Actually, let me try one thing. I bet, you know what? I bet you that this thing didn't do oops. I bet you this thing didn't do it correctly. Hang on, I have an idea. Because stream guard, stream, get stream from pool. I bet you this is it. Okay. Yeah. So you can't do this. Time with Tiny Brat. So far, so good. I need to spend more time with it. Right now, I'm fighting other demons. It's like, it's good enough that I think we're gonna probably go start using chunks of it, but it's not good enough yet that I can just swap it in place of Torch. It doesn't have the performance yet. The design of it is like, The design of it is quite good, I think, overall. I wish it weren't implemented in pure Python. I wish it were actually like implemented in C or minimal C++. Um, there are some things that causes as well that are annoying, but yeah, this is supposed to get us a trace. Hang on. Like, look, this is supposed to give me a trace, but it just doesn't. I'm trying to think what I can do about this, man. Anybody know? Like, the thing is, there's just very little example of what I should be doing with this. Sample video. Example. Kernel. CUDA. Wait, graph. So I am using, this is Torch's graph wrapper, right? So it's slightly different. Honestly, NVIDIA stuff is like way better. This is actually pretty nice. But apparently there's some conflicts that Torch catches. Environment. Yeah, but this is... Do I need to do... Maybe this? Let me just make sure real quick that this doesn't do anything. Anything weird. It's like undocumented evil APIs. Okay, what do we get now? We get the same thing on linear, yep. What's this? Okay, I mean, this is not going to be useful, but we'll do it anyways. Because maybe it is, you never know. I could have messed something up. I don't think it was possible, but I could. It's definitely not in negative strides. I like how, by the way, like, it can't even get a one-line torch check call, right, without hallucinating methods that don't exist. Get from this. Op shape. Ops can take. Let's try to check. Shape. Hmm. Yep. It's all fine. The thing is, these are not. And this is not it. I can try this. Do we have this? I'm gonna use the restroom while we do this and go grab myself another cup of tea. Okay, here's what we're gonna do. We're gonna make a small neural net, just like a one layer thing, and we're gonna see if that works. Because otherwise it's gotta be something with just the API, right? What we're gonna do. This. Okay, so here's our network. Then we're gonna do this. We're gonna minify this. Welcome, Quinn. Yeah, so we can do like this, right? Wait, what? Oh, come on. Why did it install? Why did it do this? Piece of shit. I swear, it just went and installed the wrong... I should have checked. Yeah, I know I have 13, but why the fuck does it just... Why does it install the wrong version when I go to install? That's so dumb. Does anybody know how to fix this? Well, I mean, I can just install this one. We can just do this, right? That's so frustrating. Just installs conflicting drivers. Okay, but the idea is we're going to do like a tiny little network and we're going to see if this works. I guess we'll have compute sanitizer as well in case we need it. Yeah. Alright, enough of this. Come on. So I think if this works, we can just incrementally like keep testing stuff with bigger chunks of the network until we have it. If this fails, then we know there's something wrong in the setup, right? Actually, I'm kind of curious. There's no warm-up on this, right? There should not be warm-up. Right? Isn't this bullshit? There's no reason you'd need to warm up coup de grace capture. That's a PyTorch thing. Oh, I guess it's because PyTorch might do something different, right? Okay. Interesting. I honestly, at this point, I just wish I didn't have to use Torch. I wish we had just a library that was good, but there's nothing. Largest industry now, like biggest, like AI is billions and billions and billions of dollars, and we do not have a decent tensor library. That's ridiculous. It's actually just real quick. Yeah, so we should not have to warm it up. Okay, so that'll be good, right? Because then we won't have to do any warm up, and it'll just be one forward pass. So basically, we will have the equivalent of, well, we'll actually have the equivalent of a very sophisticated compile, a very sophisticated compile setup. But without the overhead. Okay, so this is yet a different thing. Still better though. This will be much more consistent. Okay, does this compile now, or are we gonna be stupid? God damn it. Why do I have CUDA 12? I just installed... Is this an apt package? I have CUDA 13 on here. Dude, I hate... This shit is so obnoxious. This is why I always do everything in Dockers, by the way. Because now I'm just, like, kind of screwed. This is still wrong. Well, I just installed this, actually. Do I just have to... No. I just installed this and it's still not showing. Well, now I no longer have a working machine, so that's lovely. Because I didn't check that the version being installed was compatible. I just assumed it would be. Yeah, that'll break my system, dude. That'll break my system. That'll, like, the stream will end and I will not have a computer today. I don't understand how this is still... I just installed 13. Why is it still showing 12? I mean, I'm gonna have to move this onto another machine otherwise. Yeah, because this is gonna be... I'm gonna have... Like, this is not gonna survive. Alright, so lovely. I literally have to move to a different machine. Because otherwise I'd have to reboot. Good job. Well, duh, they're all first world problems. They're still problems. If anything, their problem's more directly related to why the fuck we're stuck in the current area rather than sci-fi utopian future. This is a new machine. I need to go get a token. Let's see. I think it's actually I mean, it absolutely shouldn't just like fucking install a. It should not automatically go and fetch the wrong version of the toolkit that will break your system. Okay, let me go get a token. Now we're gonna have to quadruple authenticate everything. Lovely. I'm sure. So give me a few minutes, folks. I'll get this onto the 5090 machine, and we'll go from there. Go find my phone. Hang on. Okay, get a token. Nuts. Okay. New one of these. What's this? Cool. Okay. What's wrong? Oh, okay, this is legitimate error. Cool. We're back. We can get this done. Device. Torch linear plus. Does have a device. And come on. Okay, this thing's brain dead. Lovely. Okay, this thing is fucking stupid. Lovely. Well, I guess we're not gonna have. Remember device, really? Are you only supposed to move modules? But this is a module, so how does that make any bloody sense? Oh, two. Weird, you know? Very weird. Okay, cool. Now we have this. And what the hell is this? Yeah, this is garbage. Yeah, this is garbage. We don't care about this, right? Yeah, we get rid of this. We are gonna get something to work today, I swear. It's like... It's like I almost can't afford to, not have stuff working. Because there's really nothing more demotivating than like working hard all day and getting nothing done because the tools you're working with just suck so much. Okay, it's supposed to be like this. This is supposed to be it. We will be able to see quite soon what is wrong with the graphs. Cool. Oh, come on. Stop. Gotta reboot the container. I mean, you just see the comedy of errors, right? Like, every little possible thing. But this is why this is why, I mean, this is why I work so hard building this stuff, right? Because it's like, I don't know, what would be more demotivating, right? In some sense, if everything in the world were actually built competently and you basically had no ability to improve anything meaningfully as an individual because everything is done correctly, or if things are done comedically terribly and actually pretty much anywhere you look, you can just like massively, massively improve everything. Okay. Was it? Capture graph. Yeah, there it is. Okay, Python. Okay, so we get an error. And it's got to be right. Well, let's get the whole trace command, right? Oops. It's right there. Okay, so now we know. Now we know for sure. Because 1084. Oh, wait, what's this? 10084. Why don't we get the Oh, we don't get line numbers here. Hang on. Yeah, let me compile this with debug. Oops. Welcome, FBR, welcome. Merry Christmas. Brainless stream when? Pretty much towards the end of any block of work in which I need to do. What the hell? Pretty much, yeah. Any end of block of work in which I've been working on ridiculous things for a very long time. Okay, this debug equals 1 is really annoying as well. Debug, let's do like this, let's do like this. Let's do like this. Yeah. Rebuild. Do we have line numbers? We do have line numbers. Perfect. Okay, so right here, you see? We get line numbers right there. First thing, I want to get rid of this, just see what happens. Yeah, now we're actually going to be able to make progress because now I know it's a setup issue, right? Because it's not the whole network, it's one linear layer. We get cuBlast status not initialized. So this should be the real error, right? Message. This one. I don't see them instantiating cuBlast. Okay, let me just see if it is the warm-up. And PyTorch is so annoying. Still get the same error? No, so we get a different error. Can I go find an example? I literally just can't find any. Get stream from pool. Let's do this. That crap. Okay, I mean, this is actually usage, at least, of the library. Capture. Let's see if I mess this up. Warm up. Stream capture invalidated. Well, I mean, I can just use... Yeah, warm up, okay, same stream. It's down to here. Not need this. Leave it though. Some freaking thing. Get stream from the pool. What happens if I do this? I mean, it's the same friggin' thing, no? Except maybe I get no error at all. But this could be eating... I guess this could be eating some of the error check handling. Okay, same thing, right? 12, which is right here, yeah. Okay. Does he do synchronize? Actually does not synchronize, right? Maybe that breaks it. Failed. 10, okay. Warm upstream. On side stream. This one is using a separate stream. We get CUDA error, stream capture invalidated, and we get this on the same line. Yeah, so we get so weird. That's not very much information in video. It's really not very much information. This is the official PyTorch tutorial. And let me see if I'm using the correct. All right, so this is, where's this tutorial doc from? So, CUDA graph. Okay, so we get this graph, right? And then graph, static cast, CUDA graph star. Yeah, okay. And then we do, what is it, graph, capture begin, train step. I'm going to copy this chunk exactly because this is from the PyTorch tutorial. Unless Grok has something for me. Nope, Grok is stupid as usual. Cool. I'm going to try this exact piece of code. So I'm going to do like, do they have a guard? They do not have a guard. Okay, so what we're going to do is we're going to do like, graph. And then we're going to do it's going to be stream. So it's up here. I'm just going to do stream from pool. This goes up here. Set to warm up stream. Am I using the wrong function before? Again. I think I might have been mixing the NVIDIA and the Torch functions. Let's see. Cap stream. And then I can just comment the rest of this crap for now. And just take this exit as well, like this. Is this identical? Set the stream. Go try it. That's TF. I just want to make sure it's not this. Because it could be. Okay, the compute type changed. Really? Definitely not this then. This is super old. This is an old thing. Different. Actually, don't know which of these it is. Just pass it to both. Wait, 12.8? Oh yeah, no, because it's supposed to be 12.8 on this mission. I think it's plus args anyways. I thought it was maybe a compiled arg, but it is actually just yeah, oh, well, I'm dumb. Of course it is. Brainless stream now, apparently. Ah, okay. Doesn't help. To a previous error. How do I get true blast status? Warning. Usually caused by CUDA memcopy async failure. Keep going on this. You'll see. Okay, so now we have, where is it? Where's the line number? Yeah, right there. So we have this. I mean, this seems like a setup error now, right? Okay. Let's see what we have from this. I don't think this is it. Yeah, same error. I guess we can try this real quick, right? Okay, so this one works. Hey, welcome off market. Congrats, man. I just want to compile this as a standalone. Actually, let's just graph this. This one, this is an SSH session, 5090. And there, I mean, there you go, right? $40.90. Was it $40.90? $50.90? Yeah, it's $50.90, right? Okay, so we can just do this. I have libtorch installed. It's not preference. You're just trolling if you're not working on Linux for this type of stuff. I do. Find package. Fuck. Extract it to a folder. Okay, this I can do, right? Oops. Oh, dummy. Yeah, that was brain dead. Okay. Oh, come on. So shit. And now it doesn't have context. Add executable. You know what, screw it, this should work. The source directory. This. No such file. Make file. Did I screw up? Get this. Okay, so this one works. That's what I needed to know. That was obnoxious, but... So this is the exact same piece that I have from before. Okay, so what we're gonna do... We're gonna make this exactly the same. I use a restroom real quick. I'll be back in a minute, guys. We're gonna get this to work. This is just a massive All right. I'm going to make this, actually, let's go for exactly identical, right? We're going to take this exact freaking code. How many programming languages do you know? I don't know. Like, know well. 2 useful programming languages, C and Python. Stuff I've worked with like ever. Java, C++, CUDA, fuck else, C Sharp. Did I say JavaScript? I guess that. You can kind of pick up new languages in a couple of days most of the time. That's like a completely irrelevant measure, though. The only wrong answer for that is 1 if it is JavaScript or Python, or 2 if it's JavaScript and Python, for the most part. If you write C, then you'll be right at home because we have, I mean, Puffer's, I don't know, 30, 40,000 lines worth of C games and simulations that we use for reinforcement learning. The mug would be able to be smaller if I did not have to debug so much complete and utter bullshit. But I need a big mug to keep me through this. So if this fails, then we have a setup error of some type. Not an actual error in the code. Okay, we have a setup error of some type. Lovely. What was your question? You'll have to retype it. If you tried to link something, it probably chomped it. If I don't see your question there, though, I didn't see it. Like, if you don't see it up there. I recompile? I did, right? Well, that's bizarro, right? You see this? It works. I wonder if it's this. What happens if I do this? You can post it in Discord if you'd like. It's discord.gg/puffer. Okay. It's the frickin' environment. Somehow, when we create the environments. Oh, that's mega cursed. What keyboard do you use? I think was it this thing? Widow B4 75% with orange switches. It's like medium clicky. I also have, a compressor and stuff, so. How do I get into the buffer stuff? Not technical. Well, you'd have to pick up some programming first of all. The context here is I'm an MIT PhD in reinforcement learning, right? I've been working on this stuff for a very, very long time. We do have people who were not technical and did get into Puffer, though it definitely took some effort. A lot more effort, I'd say, than if you come in at least knowing some basic programming. I have some guides. Like, all of my best advice for newcomers is on the articles. This is probably the best one here to get started. Now, this doesn't actually direct you to a specific course or anything. This does save you a lot of time, though, if you're new to programming. Because, this really has all my best advice. This will save you a ton of time learning. So you should at least get some basics here. And then once some of this starts making sense, I have my RL guide here. And this does actually take you through the process of building a simple environment. But it is going to, at least the starter sections are going to assume that you have some programming background. And it refers you to other materials as well. I don't like to jam the credentials, but the point is, this is a very advanced area of research. It was completely inaccessible 2 years ago. The good news is it's getting a lot simpler. I'm working very, very hard to make this a lot simpler, but there's still definitely some stuff you need to know. It's not the type of thing where you can just download a thing, run it, and have it work. At least not with custom stuff, though it's actually getting pretty close. You still need to know some stuff. There are a lot of new people in the Discord as well that are pretty helpful. MIT recognized your work. Well, I mean, I have the PhD, right? So like, yes. What do we do? Oops. But before we just, I think I have an idea on what might work for this. Can I just do CUDA device synchronize? Let me see. I think civil engineering and going to trade school. Hey, trades are very respectable, man. We honestly, we have a ton of really shit engineers around that do negative work. I don't think I've ever met a plumber who does negative work. If I just do CUDA device synchronize, let me try something. I bet you this does something, right? If we just, let's put this back. This still fails. Interesting. Is it not thread safe? I'm Joseph. I am a researcher in reinforcement learning. I'm building a stupidly fast library that lets AI play games at like 10,000 times real time and learn to play them by doing it. It's used for a bunch of other stuff, but that's the quick version. Yeah, Anish, honestly, like, even at the top schools, it's only a fraction of the people that come away knowing anything useful. I honestly think a lot more people would be way happier going to trade school than trying to do stuff in tech that's like total bullshit. Like, I mean, because the thing is, university really doesn't teach you a lot of the practical stuff. You're way better off learning most of that on your own anyways. Um, Although I am in tech, I did not get any of it. Yeah, that's about right. Um, if you want demos, we have them at puffer.ai. You can like play around with our agents. It's just like you can think of it as we train small models on games and we train them ludicrously fast. We don't just train on games, we train on other types of sim, but for research we use games. Well, so that we can do this right now, let's at least, here, we're gonna keep the example in there, but we're gonna just move this. Okay, so here's what we're gonna do, right? We're gonna keep this example. Okay, and then we're going to get rid of a lot of crap. These are going to be contiguous. The policy. Yeah, this is fine, right? It's literally just this chunk. Everything else is just bullshit. Okay, so this tiny little piece of code is what's been driving us nuts all day. I will say I had a handful of courses that were very useful in my undergrad, but most of them were a massive waste of time. Learned Android dev, not many Android jobs, job in hand, not happy with it. What about other tech? Um, well, if you just learn to program and you don't just learn Android development, you should be able to very quickly pick up other skills, right? So pick something interesting with jobs, learn it, and then try to go get a job there if you want. How is Python? What do you mean, how is Python back? How did you learn to program using videos or books? Honestly, very stupidly, and it took me a lot longer as a result. I had some like Java in my high school, and I wrote a bunch of Minecraft mods. Java is a terrible language. It teaches you terrible programming habits. I picked up MATLAB over this one summer doing like really basic AI stuff. And then I started trying to like write my own neural nets. And I spent a lot of time when I was 16, 17, just trying to figure out how to write neural nets in like mostly Python. Picked that up. And I wrote a lot of really bad code for a lot of years. And I spent a lot of years trying to figure out how to write better code. And most of my like courses, they actually do not teach you to write good code at all. They teach you to write exceedingly bad code. So I just had to get better as a result of doing my own projects and doing my own research. Um, and then frankly, all the low level stuff has just been in the last couple of years since I finished my PhD, because the amount of engineering that was required to build Puffer was something that I could not do during my PhD. It was just too much time. Backend dev in Python. Yeah, Python backend kind of gross. No, Java is not good. Java is like a crime against humanity. That thing should not exist. Here, let me show you why Java is so stupid. This is the project that this was the project that I was shown during high school when I was like learning stuff. Like this was the example of good code and stuff, and it was used for this. This is like hundreds and hundreds of files. You can literally implement this thing in about 300 lines of C in a couple of hours. And we even have like a little prototype. I never finished it, but like you can implement that thing about 1,000,000 times faster. And like this is a few hundred lines of code. Like you can like fire, whatever. So yeah. Like the language itself forces you to write bad code. It's ridiculous. Went to Stanford. Some of your classes had to be world class, but kind of, yeah. Thought you were an undergrad. I'm 28, man. I finished my PhD almost 2 years ago now, and I've been building Puffer ever since. This is all open source, but it's also a company. We do ultra high performance simulation, and I do a lot of research in public. So that's the idea around here. Is this is like, cutting edge research, combination of performance engineering, algorithms, architecture, ton of other stuff, and I do it all right here. Mostly projects, yeah. Okay, cool. So observations must be B input size. Where's my network? Let's get our torch stack trace. Oops. No, not from Stanford. The PhD is from MIT. Stanford was my undergrad. Just done for the day. How's CUDA going? Well, we just figured out the thing that was getting us stuck. There was this crazy conflict with the end vectorization, where somehow like some of the streams are conflicting with trace. And now I'm in the process, now that we figured that out, I'm in the process of reintegrating stuff. Oh yeah. Yeah, if anybody around here is new, just start Pufferlib on GitHub. It really helps me out. It's all open source. This is when I started working on it full time. size. 70. Ah, is this, yeah, this is a problem. How do we do this? Yeah, this is a big problem, right? Because I need this, okay. Yeah, so we need this. Should I contribute dumbbell sampling? He's talking about and create a good PR. Lance, can you create what would be really helpful if you just like made a micro benchmark, basically? Can you get like it should be pretty straightforward to get a micro benchmark of like basically just showing the perf difference. You can do it in Python if there's actually a perf difference there. It would be better in C++, but you can just stick it there. And I just want to see like I essentially want to see that diff. And like do it under realistic conditions as well, right? So batches of, I don't know, 2,000 or 4,000, relatively small number of logits, that type of thing. Public opposition to data centers. The only politics around here allowed are things that are directly, and I mean very directly AI. Everything else is like, just keep it tech focused. Public opposition to data centers. I don't think there is public opposition to data centers, though. Fear-mongering. I mean, that's all bullshit, like, though, right? I mean, that's essentially just, like, vested interest bullshitting. There is no real opposition. It's like people lying and saying that LLMs drink a lot of water or bullshit, right? On breakout, it doesn't even need to be on breakout, man. A micro benchmark would just be like, time the sampling operation. Now you do have to make sure you're not caching, and you have to make sure that you're actually getting new RNG or whatever every time. Because I remember that I tried this Gumbell Softmax a while ago, and I think you just ended up bottlenecking on RNG generation. You're free to like go ahead and try it though. NIMBYs for data centers. Well, yeah, that's reasonable. You shouldn't have a data center in your backyard, but there's plenty of space to build them that's not in anybody's backyard. So, like, there's a lot of open space in America. RNG is fine on our impl. I remember playing with it a while ago and it not working, so if you have a benchmark for it, then absolutely. Because, like, what I'm going to want, Lance, just to give you an idea, I've been working on this, it's in 4.0 at the moment, test, microbench. Right, so I have these tests of a bunch of different, it's mostly right now C++ versus kernels, but I'm going to want to have a very nice benchmark that has essentially all the custom stuff that we've done that's non-default, so that we can see that all of our stuff is faster and by how much. Neptune going dark because of closed AI. Yeah, I saw that. So we're going to have to switch back to Wanbi. Battle environment bonked with current, the one with ocean. Yeah, so that's an unfinished environment. It's not listed on the website. It's just like unfinished. I don't remember what state I left it in. There are some cool screenshots in the Discord though. It's like this large scale environment with a bunch of vehicles. Enough existential crisis. Hey, drop by whenever. There's lots to learn here. Is there a PR or something where I can look up the state? No, but you can see any of the environments that you see. Like if you see environments here on Ocean, these are stable, right? So these are the ones we're advertising that we have and that are good. And then stuff that's not in here is, well, not there for a reason. Large agent team-based environment. MOBA? Probably do some stuff on MOBA. If you want way more agents though, then like that's kind of tough. There's some stuff you can do with the drone ends. We obviously have Snake that you can hack on if you want to do something with that for coordination. Neural MMO, similarly, like that runs a lot of agents. You can put them in teams if you want or whatever. Dynamic varying agents like park on side when inactive. Wait, large agent team base setting. Dynamic varying agents. Dynamic and varying agents is generally a complete and utter pain in the ass and virtually impossible to do well from an infrastructure perspective. It was one of the worst possible things in my PhD. I strongly recommend not doing it when possible. You kind of always want to have like a close to constant or close to constant number of agents if you can at all get away with it. You lose quite a bit of performance on virtually any implementation that you can come up with. There's a very good reason we don't do that here. It's technically, I believe it's technically possible to come up with a pretty decent one. You literally need algorithmic level changes for it. It's really annoying. Mask inactive agents, think of action masking. Yeah, that thing messes stuff up. That exact thing breaks stuff, I'm telling you. Because you're messing with your batch sizes, okay? Like you're messing up your batch sizes, and unless you start with a massive number of agents and a lot of ends, if you end up with very few agents actually active, you end up with these tiny little batches. You break a lot of stuff doing that, and it's just generally a pain in the ass. It's like, unless you have a very specific reason to do it, it's not worth it versus the large number of other very cool and useful things you could be doing. And assigning a credit. You're still getting null data, so you're essentially messing up. Like your batches have an uneven amount of real data, or you have a very small amount of real data compared to what you expect. There are like a ton of different ways you mess stuff up. It's actually, there's a decent chunk of my PhD thesis, which is online, devoted to talking about that mess. It's not fun. I'm probably the person who's most qualified in the world to tell you that as well. I think probably there might be a couple other people who dealt with it to the level that I have, but not many. Read it this weekend. Oh, it's going to be very long and boring and repetitive. I don't recommend reading the whole thing. There are a couple sections though. You can kind of see me trying to come up with ways around it, and it's just such a pain in the ass. Ooh, that's actually really gross, isn't it? I wonder if I can just do this. Like, segfold. Huh? What? Hmm. Oh, it's because of reset, right? Yeah, it's gonna be this. Ah, okay. This is a real error. Cool. That's a real error message. First real error message of the day. Yes. Nice. We get to replay. So, we actually have to record the graph correctly in order for this to make sense, which we're not quite doing yet, but this is solid progress. So from here, I think I can make stuff work. I'll still have to figure out the environment setup threading stuff, but I can make things work from here. Let me use a restroom, give me a few minutes, and then we'll see if we can crush out a torch coup de grace, or a, what is it, coup de grace forward path. Okay. I'm starting to get hungry. Another hour and a bit with another hour and a bit in me though. So, next chunk of work here. Graph. We're just gonna be lazy for now. this. Try this. I want to see if this works. Because I think you have to crap enough buff, not bug. Grab some bug. So goal here is we capture different graphs. I think this is the correct thing that you need to do. Suppose we shall see. Like a lot of stuff hard-coded, but figure it out. Okay, yeah, this needs to be void star is not a pointer to an object, right? Can I not just make this was there some reason I did this? Oh, and then I guess this doesn't need to be calect now. invalid use. If that does it. Okay, cool. So we get to where do we get to? Okay, we get to here. Okay, and now we don't error until here. Perfect. Okay? Perfect. Prob dist must be 1 or 2 dimensional. Okay, now we're actually in a relatively good spot. Yeah, because these get allocated like this. And end logits do not need horizon. These get two. Okay, and then we need to do, we need to actually trace the copies, I believe. We may as well trace that. Right, so what we can do is we can put the capture begin up to here, like this. I think we're going to end up being able to do this with one buffer, actually. Yeah, we'll totally be able to do it with one. We'll leave it like this for now, though. And this is output is policy forward. Forward. And now this one. So we do like this. Logits value state out equal ops. State batch like this. Similarly, oh, and then we also have to do, what is it? End logits. I think we're going to end up with a copy issue, but it's fine for now. Because it's going to be like obs, what is it? Obs, narrow, what is it? You don't need to copy obs in actually, right? It's going to be env, logits, this. Yeah? And value, it's going to be something like this. This is very difficult, but like this is going to pay dividends because this is going to kill like all the CUDA launch overhead pretty much. What does not mask the broadcast shape? Once this runs, we will be very close. Because I can just copy, this can go into a function. Did this give me a new error? No. no, this is weird. Start plus length exceeds. Huh? This is initial state 8192. Initial state. Interesting. Oh, I see it. Right. State out. Okay, so you copy this into state like this, right? And now we get to line 1153. Perfect. Absolutely perfect. So I think what we want is this. Just want to take this. Honestly, let's just make a function, right? Void forward. Okay. I'm going to take this. Let's just do like this, right? Buff like this, yeah. Now we just have to do this call. Policy forward. Log props actions like this. Doom is source. Yeah. I looked at it briefly. There's probably some stuff that's pretty old in there, I would say, but I mean, there's also a lot of crazy, crazy groundbreaking things. I don't know, figure out how to make a cool Doom mod would be an awesome project, like semester project to learn stuff with, right? Running Doom in Minecraft. I don't know why people do that, man. Like, writing an emulator of some type is probably a very good project, but there's no reason that you need to write the emulator in goddamn Redstone. Alright, you can be a normal person and write it in C. Ever thought? Of course it's possible. I think, isn't Redstone Turing complete? And it's like a really shitty emulation language if you think about it. It's just a really inefficient. Are these people still building that by hand as well? If you're building that by hand, that's like awful. But you can literally, you can write a compiler that will output for you like whatever you want, but instead of being assembly, it's Redstone. Like, that is a thing you can do. Like, technically, I'm pretty sure you could even write a Redstone JIT if you wanted to, so that it runs it first the normal way, and then after that it just compiles to assembly or machine code. But there's not much reason to other than it being a fun nerd snipe. New char? What? New chair? Ah. No, I'm just in Florida. I am a migratory creature. I work seasonally. I actually wasn't. Like, I never even figured out how Redstone worked properly, other than a couple dumb things. The only games I was ever like legitimately very good at and discovering new things before other people was MMOs. I'm terrible at every other genre of games. All the Souls games. One, two, three, Elden Ring. So I never played Bloodborne. The rest of them, yeah. Not really, honestly. I preferred three to Elden Ring. Like the open world version of it basically forces you to use a wiki or just have a completely terrible build. Because like it's way easier to miss the one item that you really need and will be terrible without in something that big. I know the thing that's weird with that formula from a game design perspective, right? Is the idea is that you're supposed to be able to go around and like explore and be rewarded for it, but instead the way that those games work is that you explore and 95% of the time you're not rewarded for it at all, and then 5% of the time you find the one thing that you really really need. So if you miss that, you're just screwed. So yeah, I don't think the exploration formula really worked as well in that. Unless you're playing with summons, but then are you really playing the game? This is fine. I think we just do. It's not grind though. So grind is when you have to do the same thing over and over no matter what. In this case, you can beat them first try, you're just bad. I mean, you want to see grind open RuneScape. No matter what you do, you have a minimum 500-hour mid-game. Yeah, so what we're going to do is I don't know. I started over my vacation. I needed something to do in a couple of the evenings or a few of the evenings, so I started playing WoW because I'd never actually really played that game for more than a week or two. And I'm supposed to be the MMO AI guy, so it's kind of weird that I haven't played the biggest one. And they have completely like ripped that away from the normal MMO formula to the point that it's not even really an MMO anymore. It's kind of like I don't know, it's like a seasonal party game with a bunch of mini games or whatever. It doesn't really have the same progression element at all that defines that genre. I played a little bit. I didn't really play that many FPS games though. Like I played a little bit. The vast, vast majority of all of my hours of games are in MMOs. Oh yeah, I remember. I think I had 300 hours on Emerald when I was very young. It was the most played one by far. Okay, so we make it to here. And now, action buffer. Yeah, so this one here, this needs to be this, right? Under log prob. This. Let's just need this, like this. Okay, so you get log prob. Neural MMO is still up. Yeah, all of their old blog posts are. Log prob. We are going to make this stupid thing work. At least I'm no longer just debugging this blind. Now it's like pretty consistent. Two. 1160. Buffer. Obs. How's this reward supposed to work? Okay. This runs. This actually runs. Perfect. I'm going to commit this. This is not going to train at all until I fix about 1,000,000 things, but it runs. Okay. Committed. So, lots of stuff to do from here. Lots and lots of stuff to do from here. First of all, I want to compile this with... I want to compile this without debug on. So this number here is not going to be a real number. Interesting. So what's it getting delayed on? If I just... Hang on. LinkedIn. Do I even have one of those? Is it not on there? Is that not it right there? I don't know. LinkedIn's lame anyways. Hey, welcome. $3.7 mil. Okay, so something is wrong because this should be way faster, right? Well, how is this even working with... Oh, now I'm confused. Yeah, I don't know what that is. Man, that's, I wouldn't be surprised if they do it. That company writes garbage. What's happening here? What is happening? Oh, train's 85%. Huh? Something's broken. Because this was faster before. I have some other stuff running on this. Check that next. What? Hello? This is a Python kill-all. Some garbage. This one is always the one that freaking works. There. How's it work? Pufferlib mu. I believe so, yeah. Though I'd suggest just using MJX or something and then using that bind. It'll be way faster. So something weird happened because this was way faster before. Yeah, this was like way faster before. It's with the fused loss. Not that I saw, man. I mean, he got his profile wrong by a factor of 80. He didn't read like the correct comparison. So kind of like distracted me for a couple hours, and I thought that because the thing is, if you actually got an emulator to be 80x faster, it would be a huge deal for AI in general. Like that would be a massive, massive contribution. But like the thing is, you need frame skip to be accounted for correctly in that number, and he didn't account for the frame skip, among other stuff. Something weird happened because it got slower. It was faster before. Like, and it's not even the section that I played with at all. Oh, I know what it is. I know what it is. I got it. It was this. Gotta be this, right? Yeah, rip that. This is why traditional interviewing path just sucks. Like, it's not that hard, realistically, right? Like, if you were to spend a fair bit of time, you could get good at those, even if it's incredibly frustrating. But, like, getting good at interviewing for jobs is not the same as getting good at doing jobs, which is why the majority of software produced is utter incomplete shit. Because they're evaluating people on a criteria that has nothing to do with their actual ability to do reasonably good work, even passable work. Okay, it's good to see that this actually has a huge impact. So this is now, what's that, 9 mil? I put the Ford back in. This is not real numbers, don't get too excited yet. So, I mean, I'd be pretty surprised if you could do just like, the same stuff and make it way faster. I'd have to really look at it to understand how much room there is for performance improvement. Yeah, exactly, Anish. That is the problem with traditional interviewing. So like I chose to just never do that. So if you put Elite Code Easy in front of me, you'll make me look like an idiot. But in fact, you're the idiot, right? For asking me a dumb question and expecting that to correlate with anything. Um, so I mean, I run my own company. It's now profitable. It's growing. I'm doing cool stuff. I'm contributing to science. But like I also have credentials to fall back on and lots of other stuff I can be doing, right? So it's difficult to recommend to people that aren't in that position. But yeah, it's like I can't just say, hey, yeah, also just waste the next 3 months of your life prepping for interviews either, right? I can't say that in good faith. It's kind of just a dumb situation. There are definitely places that you can get hired at without having to do leak code. Um, And they are probably places that will have better people, but it's not going to be as easy, right? You have to actually be very good as well. 7.2. Can I do this vec receive in here? I actually don't even know how this is running. Yeah, so that's about expected, right? Let's keep it like this for now. Didn't I comment? Yeah, exactly. So, I mean, this makes sense, right? That this is like this. Okay, so the 7.2 mil. This profiler is also breaking now. It's annoying. Yes, okay, so we're gonna have to figure this out before we can profile. I suppose I can do it without threads, right? Maybe that'll work. Can't make a calculator, Joey. That's funny. The thing with programming is like, there genuinely is not a set of stuff that you should just be able to do off the top of your head. Like, the thing that you're going to be able to do quickly without having to check docs and stuff a whole bunch of times is pretty much just going to be the exact thing that you've been working on for the last couple of weeks. And other than that, like, it will take you slightly longer than instantly to figure stuff out. Okay, this runs. Illegal memory address, really? Really? Do I need to, like... Nah, Ubuntu. Okay, so how are we getting illegal memory? Actually, we should do it this way, right? Look at the bite out of performance that blocking launches cause. Well, now it doesn't break. So presumably it's a synchronization error. I'm trying to think what this could be. Oh, you know what this probably is? Okay, so this is apparently fine. Okay. So, right. That makes sense. That should be fast, right? What have I missed? We have like some basic thing working. We have some synchronization errors. It looks like there's some speed up, but I don't think we're seeing the full thing that we're expecting yet. It's probably just a really bad idea in general to have this be shared. So let's just do torch graph obs. Oh, this is way easier to do it this way, isn't it? It was way easier to do it this way. Yeah. We're gonna, okay, I was a bit stupid. Graph obs actions. Graph state. being dumb. What games do I play? Well, when I'm working, not much of anything. I don't know. I downloaded WoW over vacation. It's okay. It is nowhere near as addictive as the other MMOs I used to play. I mean, obviously, I used to play a ton of MMOs, right? That was like, I did my PhD thesis on AI for MMOs. Like, come on. So, wrote a game end to end. It's not fun yet, but it's a game. It works. Cool. Did any of the emulator stuff end up working? Honestly, off market, they're both going to keep claiming victory back and forth every few months for the next couple of years, while both being way short of what they say they can do. About how it goes. Compiling its half transpiler state. Well, I mean, like, the benchmarks, right? Screen graphics. Like, even if you got it actually 10x faster than, like, not 80x faster, but if you got it even 10x faster, it would be still a pretty big deal. 10x faster would be, like, a bit faster, I think, quite a bit faster than Atari. So having seen the interview, what do you think he's cooking? I don't know, Jess. It seems like he's thinking about very out there stuff and not very small deviations or changes on top of a standard LLM, which I think is a good thing for the field. Pretty annoying when I'm ruining it. Yeah, I don't know. I just ignore the people, man. Like, I still don't know anyone who I know is good, um, who is like given an actually reasonable take on any of this stuff. I don't know what the hell Carpath is on posting about. Like, I mean, it's like the thing is, it's so easy to prove as well, right? Like, there would be a bunch of legitimately good LLM written libraries on the order of 1 to 5,000 lines of code, if these models were as good as people say, and there just aren't. Why do you need 32K amps? Why do you need that? Demis is also on the compute is the way. Well, I mean, it is very likely that compute is ultimately the way, but that doesn't mean there's a difference between needing to scale stuff longer term and being able to make meaningful contributions at smaller scale. I wanted to see look, like our new vectorization is just going to have the threading be in C with GPU buffering. It'll be way faster, and the target is like at 32 kms we should be pushing 15 to 20 million steps per second. 8K we're going to hit 10 million. Need a reason to test the gill list? Yeah, I don't know. I got bored of waiting for that and I just figured whatever. There's really no reason to do like unless you're gonna do like I really don't think there's a good case. Like you wouldn't be able to do the thing that I'm doing here in Python with the threading anyways. So I really don't see much point. There's just too much overhead. I will say that the C vectorization was a total bitch to write. That was not fun to make work. But it does seem like it works now. Right, so what I was going to do here, it's like... Oh, wait, we can just do it, can't we? Yeah, we can totally just do it. It doesn't have to be loaded in at all. I believe here's what this. AI research is not automated at all. I like people just keep looking for like shortcuts to be lazy and not bother to do things. Like I don't fucking know. People just being really, really dumb lately. There we go, right? Yeah, so now we have this thing traced. We don't need this buffer anymore. It's going to be so much easier. Okay, so now we have we've got this graph captured. Call Pufferlib. We no longer have to care about any of this crap anymore. Or block size, none of this matters. Okay, and now we can trace this. And now we just have to allocate all this stuff, I think. So let's just put this before create environments. Okay. And then what we do obs. This will be 6. This will be batch. Input size. Okay. Graph actions is just going to be batch. Good. So now we have this. Right? So now we have all of these buffers. And all we need to do is just copy. So we just do Pufferlib graph obs copy underscore. State like this. Linux daily. Yeah, Linux is just what I use. It has the side benefit of not allowing me to install a few of the very addicting games. Oh no, wait, we don't need this. So it's already stored to this, right? What is graph ops doing? So Phil, what I'm doing here is I'm allocating some buffers that get reused by the network, and the network is traced with CUDA graphs. So it goes into a single CUDA call. You kill off a lot of the launch overhead, right? And the only requirement of this here is that I can't just pass whatever tensors I want for the inputs and outputs. They have to always be at the same spots. So it looks a little weird, but that's what it is. And once I have it cleaned up, it's not really going to look any worse than the original was before I did this. Yeah, I have to do graphs, as it turns out. I was going to try to do torch compile on its own and use that for graphs. It turns out that is not exactly a good idea. Get rid of this. Yeah, that's a pretty simple function to trace now, right? You only need one graph. All right. Do make sure that you're timing it correctly. I'd be very surprised if you're 5x faster than other blasts. That's something that should be basically impossible to be 5x faster in a fair test. Oh, 5x slower. Oh, yeah, my bad. Well, how much faster is the question. Yeah, I just misread. We ever hire full-time interns at Puffer? We are taking one intern for the summer. Finn will be joining us. Now, in his case, right, I basically couldn't say no, considering that he was one of two people who contributed the drone environment, and that is the best PR I have ever received. So Full-time is hard though, because the thing with full-time is, right, like Puffer is contract based. Um, so if hiring full-time basically means that I have to estimate the amount of contracts that we're going to get incoming, and I have to price in the risk of like contracts being slow here or there and stuff. Whereas when I hire people as contractors for specific jobs, it's much easier because I just split you a chunk of the a chunk of the contract value. Oh, okay. So you got slightly faster 32 thread performance. Interesting. Yeah, that seems weird then because you would not expect if your single thread is that slow, it seems like you should not be able to do that much better. Oh, yeah, something is totally wrong, dude. There's no way that their multi-threaded implementation is just slower than their single-threaded. Something's not getting timed correctly. Timing threaded stuff is really obnoxious as well. Come on. Come on. Okay, this works. Unregistered graph. And I can tell you async benchmarks are just a massive pain. The graph should be registered to the state. Oh, wait. Graph obs state. Register. I shouldn't need to call anything else. This was working before. I modified it slightly, and I think I somehow screwed up. I'm trying to think if I'm like copying the graph somewhere. Get rid of this. We don't need this. Oh wait, are you supposed to, hang on. Yeah, I see the problem. Yeah, I see the problem. So this needs to be like, honestly, I should probably just do it inline. Be easier. I see the problem. Like this. No, it's dumb. Hang on. I'm just tracing the wrong thing. It's a very simple mistake. I'm just tracing the wrong thing. Oh wait, hang on. Is this? Yeah. But then this one is part of it, isn't it? Oh, hang on. No. Hang on. I was almost correct before. You do. No, wait. Isn't this fine? No, I'm confused. I thought I was accidentally copying the data transfer. I think this is correct. see, what was I doing before? Okay, no, so this is fine that we do this in here. Oh, okay, so what the heck did I mess up then? Nothing. That's bizarre. Seriously? Oh, that was weird. Oh, it's because it's with launch blocking, it doesn't show up, right? So I have to launch it without. Still fine. Interesting. But we still get this illegal memory address thing, but that static error is expected. We didn't necessarily expect to fix that one. Okay, but we can actually, at the very least, so I gotta go check when dinner is, I might have to go. Okay. Solid, right? Now, there's still some bugs. Without vec receiver send, it's 7 mil. There's still some stuff we can do about that. Okay, so we still get this. Let me go check on dinner real quick. Hey, hey, what's the plan? What is the plan? Dinner. Yeah, let's not ruin the night made, right? Thank you. Well, when should I be done? Lasagna, meat. Yeah. When should I come down? 6? All right. All right. I got like 30 minutes to finish this. I'll be right back. Let me use the restroom real quick. Oh, man. Okay. What do we have here? Make sure that I compile this version. This runs. Yeah, so we still get this down. Okay. Go figure out what it's doing that's causing this. Recommended practices, train a model for long-term planning, a game with non-linear progression. You can go look at the Pokemon blog post. If it's like really long, like Pokemon is, then it's like not something that is going to remotely work out of the box yet. We have some stuff that's planned for Puffer 5 to help with that. But you'd be surprised that like a lot of reasonably long games actually don't require that much super long planning. It's mostly a matter of what data you're actually getting in training. Like if it's a game like Pokemon where basically all your data is from the start of the game and all your data is from the middle of the game, I think stuff changes quite a bit. Is this legitimate? No, it's not this logic, right? It's not this. And the thing is, if I do CUDA launch blocking, it doesn't break. Welcome. Enjoy your new OS. Okay. So, something is screwy. It's not the graph. Can this be your longest stream? No. It's gonna be like 8 hours and change. Okay, so this is still wrong. 8, yeah. So it's not actually erroring here. Presumably it is erroring because of the forward pass somewhere. And if I do this, if I do this, okay, pretty much I think that there's just some indexing screwiness. Still breaking. Well, that seems weird to me because I don't know. What if I just here, not do this copy either? I'll just assume any of them can be broken. Still a legal memory address. That really doesn't make any sense to me at all now. What that could have changed. Fuck. Okay. I mean, nothing is happening in this loop, so oh, you know, the only thing that's different here, these buffers. Oh wait, they're getting passed from. Yeah, they get passed in actually. How's it possible that this breaks then? Okay, so it is somehow tied to graph creation, right? And just to be sure, if I do build this graph, I'll make sure it's tied to the actual creation of the graph. How much faster could you train Dodo with Pufferlib? Yeah, so the problem with that, right, is not much faster because the environment is not fast. If you were to rewrite Dodo like crazy fast, then you could train it crazy fast. I mean, there would still be some performance that we could get, I'm sure, but... Yeah, okay, so capturing the graph somehow breaks torch profile. So it's not anything we're doing, it's the torch profile itself. Okay, so it's not something with profiling. sure. See, here we don't get it. Immediately. Um, no, I've tried Sonnet. I think I briefly tried what, GPT-5 or whatever. And the models are all just so freaking bad. No, I haven't bothered looking at Opus. I guess I could get a sub just to play with it a bit, but eh. I mean, the response I got to that post I made was mostly the people I know who are like actually pretty good at what they do telling me, yeah, that's like none of the models are gonna work for you anyways. And then a bunch of nutcases like writing a bunch of stuff that makes no sense. Okay, so this doesn't fix it. This does not fix it. The problem is it just doesn't happen with launch blocking 1. I'm not threading anymore. Just to be sure, I think this is redundant, but we'll try this. I mean, it's not even niche, it's just complicated. Like, oh, your code is niche. That's so like literally anything that's like completely new, it'll just completely fail. It's not a decel take at all. The decel take is like, let's give over control to these language models and just like build a tower of dog shit that we're not actually going to be able to like make anything useful with. Mhm. Not even. I gotta go for dinner in a few minutes. I might be back to do an evening stream. We'll see. Stuff just driving me nuts. Guten Appetit. Yeah, so I'm not even replaying the graph. You see this? I'm not even replaying the graph at all. And I'm full synchronizing. Okay. Get rid of this. Nah, I thought we had it, but no. I mean, I'm calling synchronize on this, so how can this possibly... I don't understand how this can possibly mess up. Look. Unless maybe, hang on, maybe I missed... Maybe the test was wrong. If I just do this... It's literally just making this thing somehow screws up CUDA. I don't know how that's possible. Creating the graph screws up CUDA. This will be the next thing to fix. I gotta go get dinner though. We made some good progress at the very least. So, for folks who've tuned in, thank you. If you're interested in my stuff generally, I stream a lot of dev. I'm going to be streaming a lot more dev in the next several weeks. Puffer.ai for all the things. If you want to help me out for absolutely free, just star the repo. Feed the Puffer a star. If you want to get involved with the development, join the Discord. And other than that, you can follow me on X for more reinforcement learning content.